Okay, good morning everyone. Mabuhay Pilipinas, distinguished guests and cacao enthusiasts. Welcome to a webinar that promises to take you on a journey through the world of innovation in cacao processing. I am your host, Nicole De La Rosa, a fourth year BS ABE student, and I am thrilled to be your guide for our event. Welcome for today's webinar entitled Cacao Processing Technologies, a Pinnacle of Innovation. But before we proceed to the webinar proper, allow me to explain the purpose of this gathering today. Within the framework of the BSABA program offered by the College of Engineering and Food Science, specifically the Department of Agricultural and Biosystems Engineering, we take great pride in presenting this year's webinar series. This series focuses on various specialized fields within the BSABE program, and we are delighted to highlight the crucial domain of food processing in today's session. And now, are you ready to meet our very influential speakers? If yes, can you comment any emoji that expresses how you feel in today's event? Yan, mag-comment tayo ng mga emoji kung ano ang ating nararamdaman para sa ating webinar for today. Alright, ayan, nagsisi-comment ng ating mga Facebook viewers. Let me just remind you that if you have any questions, you can comment it down in our comment section and we will read it during the open forum session. And also, completing the registration and attendance forms does not automatically assure you of receiving an e-certificate. Instead, this webinar series will issue an e-certificates to participants who actively engage in the responding to the evaluation forms to be posted later. And also, our attendance form is open until the end of the webinar. And i-make sure nyo rin na tama ang names and emails nyo para ma-receive nyo ang ating mga e-certificates. Now, we will begin our program by initiating it with an inaugural prayer, succeeded by the rendition of the Philippine National Anthem.
Our dear Almighty Father, we express our sincere gratitude for the gift of another day. We ask forgiveness for our sins, for which we lay our regrets and sorrows. Thank you for your overflowing and unending patience, kindness, and love that you shower us every day of our lives. Today, as we gather for this special event, we humbly seek your divine providence to help us share your grace to others. Help us engage in meaningful discussions by giving us wisdom, understanding, and guidance. Help us learn and grow and love one another so that we can become better children of yours. Amen.
Mga kababayan, ang pambansang awit ng Pilipinas.
Okay, to officially commence today's webinar, we have the privilege of inviting a distinguished member of the CBSUA-DABE faculty to offer a warm greetings to all our participants. She is a faculty member of the Department of Agricultural and Biosystems Engineering under the AB Processing, Storage, and Electrification section. She is also designated as the DABE's Extension Head. Please welcome our very own Engineer Cherry Flor Balingasa.
Hello, good morning to our participants, ladies and gentlemen, esteemed guests. On behalf of the Department of Agricultural and Biosystems Engineering, College of Engineering and Food Science, it is my great honor and pleasure to welcome all of you to the webinar series on cacao processing technologies. The diversified use of cacao beans in the manufacturing, pharmaceutical, and cosmetic industries generally increased its demand. It has been reported that it is positively correlated with the demand for chocolates, given that cacao is the primary raw material that cannot be substituted by any other commodity. To address the increase in the demand for cacao beans, the availability of post-harvest facilities are necessary given its important effects on the characteristics or attributes and quality of cocoa. As the country takes its position in the global market, quality requirements must be attained. Appropriate post-harvest facilities must be available in all cacao growing communities. The university has engaged in developing technologies to enhance the production processes of cacao to produce quality products and also utilize wastes into a new product. Hence, this activity will showcase the development of cacao post-harvest technologies. We will go hand in hand to learn these innovations. So, once again, a blessed morning to all.
for the very welcoming message. So before we introduce our speakers, let me remind everyone that we are currently live in the ESD, SEFS, DABE, and CBSUA-PSABI PPG Facebook page, as well as in the ESD YouTube channel. Also, we are encouraging you to like the Facebook page of the CBSUA Extension Services para parati kayong updated sa ating mga future webinars and happenings. To give you a background of this webinar series, cacao processing machines are essential equipment designed to efficiently handle various stages of cacao bean transformation into cocoa and other byproducts. These machines streamline processes such as harvesting, fermentation, drying, roasting, cracking, winnowing, grinding, and conching. They play a pivotal role in improving the quality and consistency of cacao-based products while increasing productivity in the cacao processing industry. Whether in small artisanal settings or large-scale industrial operations, cacao processing machines have revolutionized the way we enjoy one of the world's most beloved treats, the chocolates. Eto na, ready na ba ang lahat? Kung oo, pa-comment naman dyan ng kahit anong emoji para makita natin na excited na ang ating mga viewers sa ating honored speakers for today. Ayan, nagsisi-comment na sila. Okay, mukhang handang-handa na ang lahat. Kaya naman, to introduce our first speaker, she is an ASEAN engineer, the Vice President for Academic Affairs and a Director of Office of Research and Extension Services at Mariners Polytechnic Colleges of Legazpi City. She holds a Doctor in Agricultural Engineering from University of the Philippines, Los Baños, and for Education and Behavioral Management from University of Nueva Cáceres, and a former Professor 3 at Central Bicol State University of Agriculture. Let us now welcome our first guest speaker to discuss the overview of the cacao processing industry and the design, fabrication, and performance testing of cacao pod splitter, Dr. Nila B. Oñate. A round of applause, please. Virtual clap.
Hey, good morning to our viewers from the different parts of the country. And I've learned that we have a viewer from Dubai, I think. Anyway, good morning again. And I have the energy today because I have just included chocolate in my breakfast. And I really love chocolates, even if I am already a senior and a former professor of Central Bicol State University. And after my retirement in 2020, I was offered a position at the Mariners Polytechnic College Foundation of Legazpi City. And now I am representing MPCF Legazpi. So I am already marinated. Okay, but cacao really is a very promising industry because even if some of the agricultural commodities have fluctuations in the demand and the price, cacao remains to be stable and continuously have the increased demand worldwide. Okay, so let me give you the brief industry situation there. Okay. So the cacao industry has global cocoa and chocolate market size valued at 52,116 millions in 2022. Then, and it is expected to expand at a compound annual growth rate of 3.49% by 2028, so reaching 64,014 1.64 million by 2028. So you can easily see the demand for the industry. It is still growing. Okay. So we have the different top cacao producing regions in the Philippines, and this is the data. Okay, so you can see in the slide that the highest top producing regions in the Philippines, having 78% of the production is the Davao region. So 78%, and very small percentage is attributed to the different regions in the country. But I hope that in Bicol region, we have a very small quantity of the commodity, okay, the production and processing aspect. Okay, next. So this is the roadmap in 2021 to 2025, and is still in force, although some of the roadmaps of the different commodities have already updated their data in 2023 to 2025. Okay. So you can see that the cacao industry, if you have the proper cultural management practices, yan, you can see the cacao tree here, very productive. And in one tree alone, marami na siyang bunga. Okay? So, we have to improve the productivity of the cacao. And why is it that it is necessary that we have to improve this productivity? What does it entails? Okay? Maganda kasi tingnan ang grabing bunga ng isang cacao tree. So, pag maraming cacao tree na bunga, so what does it mean? So, it means that more income will be produced. Okay. And I'm going to share you the formula of improved productivity. Okay. We have to have the necessary knowledge. Kung sa number siya, yung K is 11 and N is 14, O 15, etc. So totaling to 96%. Okay? That is for knowledge. Then bukod sa knowledge, there should be hard work. So, yung H is 8 plus 1, etc. Then 98%. And the right attitude, which is equivalent to 100%. Yung mga alphabet natin yan and the Roman numerals. So 100%. This is the formula of improved productivity for cacao. Okay? And what are the existing practices of cacao harvesting? In cacao harvesting, usually, the current practice is picking by hand. Although there are also some technologies already na merong mechanical harvester. Okay? But it is not widely used yet because the farmers still prefer for the manual harvesting method. And then cacao transporting, some areas, especially on far-flung areas, may, ano siya, they use the carabaos, the horses, and the carts in transporting the cacao. Although, most of the regions already uses the jeepneys and the trucks and other transport facilities. So this was the traditional, especially in a very far areas. And okay, so as I've said, yun yung sa transporting. Then, for post-harvest handling, so this is the pad breaking and the bin removal is still manual method, most commonly used. As I've said, meron namang gumagamit ng new technologies, but this is the reality. Most of the farmers use this manual method. And the fermentation, fermentation is done using this method, yung sa pail, and then fermentation by heaps and other methods which which uses the available materials in their area. Okay, and in drying also, most uses the sun drying method. Okay, and but in this session, given this existing post-harvest processing methods, meron tayong interventions as an agricultural biosystems engineer, and of course, CBSUA, which has the workforce, which has the manpower to do the interventions about this traditional method into a mechanical method of post-harvest processing process. Okay? And later on, after my talk, may mga series of talks din about this post-harvest processing method. Okay? Then in post-harvest handling also, you have this bin storage and storage facility. Usually they use the wooden box, or as some, they store the cacao beans in jute sacks or any other materials. Usually mga plastic sacks na lang ang available. Yan. The bin sorting also is commonly done on manual method. So you can see that there are several laborers that are involved in sorting, because if you want for your cacao beans to be exported, kailangan high quality. Merong standard kasi of the beans for export. Kung hindi naman, dito lang ang market niya sa Philippines. Okay? To see if your beans are or has a good quality or not, yung poor quality beans, makikita mismo sa appearance. Okay? So, dito sa left side is the good quality beans, while itong sa right side, poor quality beans. So, may mga holes, especially if the post-harvest processing operations is not well utilized or hindi gumamit ng mga tama na process of processing of the cacao. Okay? So, ito din sa appearance, yung well-fermented brown cocoa, makikita din natin sa appearance. Okay? Medyo technical na ito, na masyadong kung how you are going to yung grading system dito, mga pang-export naman ito. So just to show you that there is a need really to have good quality beans, kasi ang pricing also in the market depends on the quality of the cacao beans produced. Okay? So after the cacao bean sorting, so grinding ang next operations. Grinding so that you can convert it to chocolates or any other processed products from cacao. Then, this is also a grinding method, manual. Then, here are some of the cocoa products that are processed. Okay. na mga export commodities na to. And now, what are the roles of agriculture and biosystems engineers and ABE students in cacao industry development? Isinama ko na to kasi the agricultural biosystems engineers and the students as well has a very great role in developing the cacao industry. Okay, kasi this is a very promising venture worldwide. Okay. So, ano yan? Yung agricultural engineers, they are involved in technology design and development. Okay. So the ABEs are needed to communicate technologies effectively to the farmer processors and link them to technology generators. Ang academic institutions are the technology generators. We at CBSUA and any other institutions in the country are technology generators. And the problem is there is a lack of skilled extension agents to bring the technologies to farmers because some technologies is not known to our farmers or inaccessible. So these are the challenges for agricultural biosystems engineers as well as the ABE students. We have to have continuous technology development. Okay. The capacity building, very important, and training and building the linkages to service the providers and markets. Then, what ABEs can do to address the global cacao deficit. Kasi even if there are several regions in the country that produces cacao, still they cannot meet the global cacao deficit. Palaging kulang because it has a very high demand actually. Okay. So, agriculture and biosystem engineers can help solve the global cacao deficit mechanization. So, this is the topic that you will be hearing until the end of the session, mechanization. So we design and develop appropriate technologies and facilities with the following desirable features. First is replicability, affordability, social acceptability, and sustainability. And of course, the concern for safety, health, and environment is very important considerations. And in all technologies, the need for gender sensitive and environment friendly technologies should be what ABEs can do to address global deficit. So we have to be concerned with the technology transfer, the capacity building and building linkages, establishment of techno-demo farms, and then developing cacao agro-processing enterprises, and through the public-private partnership and quality control of the product and standardization are very important in technology transfer. We have to capacitate the farmers, the processors, and the exporters, of course, okay? The policymakers as well. I hope that for the ABEs, or if you are not an agriculture and biosystem engineers, you are interested in cacao farming, even if you have different fields, the challenge is also different multi-sectors. for the year. Okay? So the answer is situation. So I've said that the so that is about the cacao industry. Just a very brief background, okay? And I would like to continue by the first processing operation when you convert the cacao pod into a commercial product. Kasi yung cacao, hindi lang sa beans, but also after the production, processing of beans, meron pang magagawa dyan. They're grinding, uh, ano yun, maraming cacao. Okay? So first, this is actually the thesis of one of our students at CBSUA. Ako yung advisor and I had some modifications. So, Engineer Bernadette Portuguese was the researcher. I am only the advisor. And of course, as advisor, co-author na rin itong design, fabrication, and performance testing of the cowpad splitter. We have already presented this in one of the national and international convention and some time year na ba yun? I think 5 years ago. But still, there are several features that can still be done on this splitter. Okay. So the title is the design, fabrication, and performance testing of the cowpats. For the introduction, cacao or the Pebroma cacao and the scientific names of the Malvaceae family is a tropical plant cultivated for its beans from which cacao powder and butter are extracted. And the demand for more cacao production has been increasing annually, and this calls really to have faster and convenient ways of boosting production. Kasi nasabi ko kanina sa situation na sa situation ng cacao industry talagang a very promising venture kasi hindi nagpa-fluctuate. Nag-i-increase, stable ang kanyang demand. Kulang pa nga kasi may global deficit pa nga. except for the splitting of cacao pods in order to expose the cacao beans inside. Okay? And it will help the cacao producers or processors to know the production efficiency of a mechanical pod splitter, which will enable the cacao farmers or processors to effectively calculate the volume of cacao pods that they can split per day, reduce splitting time and labor requirement, and ultimately estimate the projected returns. So, ito yung background the study. And the time-consuming process of the breaking the cacao pods with hands results really to the drudgery of human labor, which can be resolved by using a mechanical pod splitter. Okay. So this mechanical pod splitter makes cacao pod splitting much easier. Hence, designing a mechanical cacao pod splitter was the focus of this study. Now, what are the objectives of the study? First is to design and fabricate a mechanical cacao pod splitter. The next is to evaluate the performance of the machine in terms of the input and output capacity, the splitting time, the cacao bean recovery, and splitting efficiency. And last is to determine the economic viability of the machine. For the methodology, so the AutoCAD design was the basis for the fabrication. So as you can see, we have the different parts. We have the cutting disc here. Then we have the feed, the pad holder. Then we have here the conveyor assembly. Then the transmission assembly. And of course, to hold the equipment, the cutter, etc., we have this main frame. Okay? Ito yung basis ng fabrication. So in the performance testing, so we have considered or we have measured the percentage damaged beans, then the capacity, how many pods per hour is the splitting efficiency, then the cacao recovery. Ito yung parameters that were used in performance testing. So on the right side, you can see the major researcher setting up the cacao pod splitter, si Engineer Bernadette Portugues, who is now employed at the Department of Agriculture, Region 5. Okay, so this is how the cacao pod splitter works. So meron siyang parang kiniklip yung cacao pod, and then eto na yung result ng splitted cacao pod. So, di ba? Hating-hati talaga. Hindi tulad ng manual na minsan 1/4 lang or minsan 3/4 ang naano kasi using their knife. But this time, kasi may naka-clamp na siya, talagang sa gitna ang hati and there's no damage on the beans. Meron naman, but it's very minimal. Okay. So, the machine specification, yung dimension niya is in length, 1,500 centimeters length, then 500 centimeters width, and the height of 1,000 centimeters, and the labor requirement is only one person. And the rated power is 1/4 horsepower. Okay. Then, during the performance testing, we have conducted 3 trials, and the parameters measured was the input capacity, how many pods per minute were uh, were were fed to the splitter. Then we have determined the splitting capacity in pods per minute, the output capacity, then the operating time, then the percentage bean damage, and the cacao bean recovery, and the splitting efficiency. So those are the performance testing. So the average of that is the actual test. So three treatments. So yung yung per treatment, we had 90 pods per treatment. So times 3 treatments, so 270 pods ang raw materials that were used in testing this splitter. Okay. So yung performance result, them. So during the performance test, this was the result that the cacao pod splitter had an input capacity of 4 pods per minute, then 3 pods per minute splitting capacity, and 4 pods per minute output capacity. And the splitting time was measured at 0.21 minutes. Yun ang splitting time. And the operating time for the 90 cacao pods was only 19.3 minutes. Kaya meron tayong 0.21 minutes per pod na splitting time. Okay? So, when we measured the percentage damaged beans, we found out that 1.1% yun lang yung damage beans. Siyempre, hindi naman tayo mag-ano ng 100%. There is always damage. But that percentage is very minimal. And 98.9 or 99% cacao bean recovery was attained, and 67% splitting efficiency. Okay. So for the economic analysis, we use the partial budget analysis based on the cost and return analysis. So from that table, I wasn't able to include here, but this is the most important one. With the additional cost of equipment, syempre, magagamit ka ng mechanical method. So there is really an increase in cost. But with the reduction in labor cost, kasi you only use one person to do the splitting. So kung magbabayad ka ng per hour or per day, only one person babayaran mo. But if you are going to split 90 pods, okay, per minute, ilang katao yan? So ang analysis dito is yung comparison ng ilang laborers ang needed for the 270 or 90 pods per trial, ilan bang kailangan? So if you convert it in terms of the labor cost, reduced naman. With the additional cost due to the equipment, na-reduce naman yung labor cost, and nag-increase naman yung returns. Kasi you can use the splitter anytime you want. Na within 8 hours, multiply mo kung ilan, kasi very high ang kanyang splitting recovery and splitting efficiency. So in terms of the returns, mataas din naman siya. Itong partial budget analysis kasi is the appropriate method of determining the viability of an equipment. Kasi with the additional cost, meron naman siyang added returns because of the reduced cost ng ano yon, labor. So, yung difference ng advantages minus the disadvantage. Kasi yung B on that screen is the advantages or the positive effect. Ang A is the negative effect because of the added cost. So, yung difference niyan ay 27,694 based on the assumptions that are reflected in the appendices. Medyo mahaba na kasi yon, marami pang speakers na darating. So, ito na lang ang pinakita ko kasi maraming computations done. As long as the incremental change in income or the benefits is positive, that is an indicator that the machine is economically viable. Pag ang result niyan sa computations ay negative, so that means that your equipment is not economically viable, so better not pursue with that fabrication of the equipment. So anything, basta positive siya, okay yan, economically viable. Okay. So, yung conclusion nito, ng study, number one is that the fabricated mechanical cacao pod splitter is a machine which is a gender friendly and was able to split cacao pods. Kasi ang major objective natin ay dapat maka-split. Okay? Okay. So we have found that it can split the cacao pods. Then another conclusion is that the machine has an average operating time of 19 minutes, splitting time of 0.21 minutes per pod, then splitting efficiency of 67%, bean recovery of 99% with only 1% being damaged. And the partial budget analysis proved that the designed machine was economically viable. Okay, so that was the conclusion of the study. And from that conclusion, we came up with this recommendation to install additional cacao pod holders to further increase the splitting capacity and efficiency of the machine. Bakit namin nasabi to ng recommendation na to? Because yung splitting is good for only, yung mga pod holders is good for one. But we can further design or improve the pod splitter by additional mga clamps, mga pwedeng 3 more in one operation. Marami na siyang nagka-clamp. Okay, because of the time constraints and the cost constraints, isa lang na pad ang naano. But I've said that is a challenge, that there is still further improvement for this. Pwede nating instead na isa nakaka-pad, bali simultaneous, 3 or 5. Yan, medyo marami na talaga pang commercial ano na talaga yung pod splitter. But anyway, the intention of this is to minimize the drudgery of human labors of our farmers. Kung on a commercial scale, yung mga large scale processors na, you can still add, and that is a challenge to our agriculture and biosystems engineers and the students also, to further improve the pod splitter. Okay, so that is the end of my presentation, and thank you. So if you have any question later on, you can write on the chat box, as there are still uh, speakers after me. So yun pa lang ang first operation in processing cacao. We start on the splitting. So next is about how are you going to ferment the cacao beans. So thank you, and hope I was able to give information to our listeners.
All right, thank you very much, Dr. Onyate, for that very well-versed discussion. So take note tayo sa mga recommendations kasi this could be a future thesis topics para sa ating mga graduating students dyan. Especially sa mga AB students na wala pang research topics. So, remind ko lang kayo na nakapost na ang ating attendance form sa ating comment section. So, make sure na nakapag-fill out na kayo para ma-receive ang link for evaluation form on the latter part of our webinar. Now going back, understanding the cacao processing industries, nuances and the role of specialized equipment like cacao pod splitter is essential for achieving higher quality cacao products and supporting the sustainability of cacao farming communities. Innovation and research in the design and testing of such equipment are key elements in advancing cacao industry. Now, moving on to our second speaker who will discuss the design and development of automated cacao bean fermenter. She is an ASEAN engineer and a professor at Central Bicol State University of Agriculture. A doctor of philosophy and agricultural engineer, and she is also the section head of agricultural and bioprocessing engineering section at the Department of Agricultural and Biosystems Engineering. She is also an area leader of BS Agricultural Engineering 4th level accreditation, an accreditor in accrediting agency for chartered colleges and universities in the Philippines. Let us virtually clap our hands for Dr. Marife L. Pisino.
Thank you so much. A pleasant morning po to all our participants in our webinar today. Before I forget, I would like to commend, of course, the ABE students, who spearheaded this activity, fourth year BS Agriculture and Biosystems Engineering students of CBSUA. So their their professor is Engineer Lynette Alfo. So we are joined here by Miss Rose, Miss Julian, and of course, our very friendly and accommodating support or technical staff, Froy here and Marvin sa backstage. So marhay na aga po ulit sa Indugabos. We are truly honored to have such an esteemed group of cacao farmers, processors, enthusiasts. We have, of course, our colleagues and fellow faculty members, students, currently BS in Agricultural and Biosystems Engineering. And of course, I fairly know na marami tayong bayaws, nakita ko kanina, marami tayong bayaws na naka-online locally and globally. Yan. And of course, I like also to acknowledge some of, for sure, we have our partners and collaborators. I hope they are online. Thank you for joining us in today's event. So as mentioned, this webinar promises an engaging and enlightening experience for all of us as we now highlight and present some of our research undertakings under the CBSUA Cacao R&D program, particularly as mentioned on cacao processing technologies as just presented from cacao splitting of cacao pods. Now we will be discussing fermentation and later on drying and then roasting of cacao beans, then to the use of byproducts of cacao processing. So, sabi kanina ni Nicole, for our BS-ABE students, yes, watch out for the explicitly stated recommendations or research gaps that we have presented or we will be presenting for possible further studies. So let me now present to you the humble output of one of the most recent R&D undertakings entitled Design and Development of Automated Cacao Bean Fermenter. This is a part of the cacao R&D program of the Central Bicol State University of Agriculture in collaboration with 4K Cacao Farm based in Gumaca, Quezon. I hope Majel is with us listening. Shout out sa iyo. Palaging andyan siya anytime that we need her. Especially in times of emergency na kailangan tingnan yung quality ng fini-ferment nating cacao beans. So as we all know, cacao is an important cash crop from which chocolate products are derived. So the cacao industry is one of the promising trades in the country and is still growing, especially here in the Bicol region, due to the promising high demand of cacao beans in the global export. This situation is further worsened by the primary production of poor quality beans due to improper, inefficient, and unhygienic processing, especially for the fermentation process. So what is fermentation? So fermentation of the beans is considered to be the most important, or we can mention that it's one of the most crucial and critical process in the production of chocolate. It is a process of catalyzing several enzymes and microorganisms to induce biochemical reactions, thereby promoting temperature rise, which hastens the required degradation of the pulp and biochemical changes in the beans cotyledon. That is, kailangan po kasi, the beans must be carefully and fully fermented to bring out the most desired flavor, color, and aroma in the world, that is the chocolate. However, this process is still underappreciated by both the public and the farmers and our processors. So why the dire need, again, for fermentation and mechanizing the process? So nowadays, the fermentation of cacao is traditionally done in earth pits, heaps covered by banana leaves, baskets, pails or containers, or in perforated wooden boxes. So wooden boxes are widely adopted but still pose some problems. To complete the process, several boxes should be made for turning of beans. If not, beans are mixed manually using hands, making the work more tedious, sabi nga kanina. Grabe ang drudgery and of course, time-consuming, even for small-scale operations. So the beans, when subjected to these various fermentation approaches, take about 5 to 10 days to ferment. Sometimes, mas mahaba pa dyan. And these are also prone to hasty deterioration due to molds and bacteria during the fermentation process. Wooden boxes last only for a limited number of fermenting operations, hence require frequent replacement. Moreover, some of these traditional methods are considered generally inefficient, causing many losses. So, maraming under and over fermented unmolded beans. Furthermore, the byproducts from the process, particularly the pulp and juice, result in losses due to inappropriate processing equipment and facilities. So, given this, appropriate technique, appropriate fermenting equipment should be developed to provide high-quality fermented beans that can be dried and stored for a longer period without deterioration. So this study is intended to solve these aforesaid problems by speeding up the fermentation process, reducing the drudgery and intervention of human labor during the fermentation process. Of course, we made sure that we provided food-grade stainless steel material to ensure that the fermented cacao beans and the byproducts derived from juice and liquefied pulp can be sanitarily collected, thereby ensuring it safe for human consumption. Furthermore, by introducing a gender-friendly operated and mobile machine. Okay? More so, this undertaking is in support and a positive response to the milestone in the cacao industry in the Philippines. Cacao being recognized as one of the high-value commercial crops in Philippine agriculture, and to support the Philippine cacao industry roadmap vision of a globally competitive and sustainable Philippine cacao and chocolate industry built on a strong Philippine brand of quality cacao, with a main goal to produce 50,000 metric tons of quality fermented beans by 2025. Yung pinaka-goal talaga niya ay ito, kasi ito yung ini-import ng Philippines. So, sana hindi na tayo mag-import. Tayo na mismo. Kaya yung initial na goal is really to produce 50 metric tons. Ito ang kailangan ng Pilipinas. Ay, more than that actually. Kasi may napoproduce naman tayo. Pero ito yung amount or volume na ini-import natin. Okay, so that is to meet the demand of the export and domestic markets through a 40% annual increase in production. As with this, there's the increase in fermented bean productivity level is now a priority direction by specifically ensuring availability of high quality fermented and dried cacao beans to support and sustain value-adding activities through, of course, the provision of efficient post-harvest processing equipment, particularly in all cacao growing communities. So, given the identified problems, as mentioned earlier, actually, hindi siya problema. We consider it more as opportunities. So with this, the study generally aimed to design and develop an automated cacao bean fermenter, and specifically aim to design and develop an automated cacao bean fermenter. We can simply call it ACBF with a steering or mixing mechanism, evaluate the fermentation time, recovery, and efficiency of the machine, and to test the quality of the dried fermented beans and to assess the economic viability of the machine. So to develop the activities to be done to achieve the set goals of the study, a conceptual framework using the IPO model was made by first identifying the constraints as previously mentioned, the needed inputs to develop the working plans and design, as well as the processes and flow of activities to be done, and of course, the expected outcomes and concrete products of the study, that is to have an efficient and gender-friendly operated, mobile, and automated cacao bean fermenter that allows sanitary and hygienic product processing and byproduct recovery. So under the project or the program, we've already undertaken series of prototyping of fermenters before this latest prototype. So this were done in partnership with our fellow researchers here in the university, here in the main campus, here in Pili and Sipocos. We have Dr. Nila Oñate. We also have Dr. Rico D. Almonte, our former PPAF and former Sipocos campus administrator, and our student researchers who are now full-fledged agriculture and biosystems engineers. Dapat di ko sila makalimutan kasi sila ang nagsimula. Okay? We have engineers John Carl Galvez, Engineer John Carl Galvez, na ngayon ay nasa central office, naka-station under the PRDP. Si Engineer Maria Carmela Llovet. Saan ba si Carmela ngayon? Connected.
Singapore.
Nasa Singapore. So, para lang pala si Engineer Griselda Chavo. Na nasa New York ngayon. Grabe sila. Parang talo tayo sa paglipad ng mato, madam. And of course, hindi ko rin dapat kalimutan my former research assistants, si Engineer Jeff Lim, na nasa RAED, DA-RAED, Region 5, and Engineer John Smith Arcelia, one of our resource persons. Okay, so my gratitude and appreciation and commendations to them. Kasi sila talaga, yung bang walang tulugan para to make sure na may nakabantay talaga during the process. So kahit automated dyan, kailangan pa rin na babantayan siya. Yes. Okay, sorry for that. May cue na, nalobat na daw ako. Anyway, saan na ba ako? So, yun nga, again, would like to commend all those fellow agriculture and biosystems engineers. Lahat na actually sila. Ang aming mga advices, si Ma'am Mila, ay lahat na professional agriculture and biosystems engineer. And of course pala, si John is, ang advisor niya is, sana hindi ako nagkamali, si Engineer Julius 𝐷. Okay, so this one are the prototype series of cacao bean fermenters under the CBSUA Cacao R&D program. So ito yung first prototype. This is study of John Carl Galvez. Okay. Of course, yours truly, Engineer Nila Oñate, as co-program leader, and Dr. Rico D. Almonte. Actually, ang Sipocos campus ang nag-fund ng manufacturing ng ating first prototype. So, masyadong malaki ito. Okay? So, it has a loading capacity of 125 kilograms. But then, mataas na rin naman yung recovery niya, 85%. So, dito, we've determined the fermentation efficiency using the traditional sun drying and the use of mechanic solar dryer. So, we're able actually, hindi to actually kasama doon sa objective, but dahil nga that time ay hindi nga minsan may drizzle. So, kailangan at least yung solar dryer namin ay may cover. So, siguro kaya mababa yung efficiency nung sa traditional sun drying namin because affected siya nung exposure to high humidity. So, mas mataas yung efficiency ng na-try namin sa solar dryer. Okay? And yung fermentation time niya is 4 days. So, mas longer compared with yung mga sumunod. And the juice recovery is 90 ml per kilograms of fresh cacao beans. Okay. So, ito yung mga recommendations ng study na yun. So, this machine the fermenter should be subjected to further modifications in order to facilitate easy cleaning and visual monitoring of the beans during the fermentation. Masyado talaga po kasi sarado yung loading bin niya. No? So, hindi nakikita yung sa loob. And then, the juice outlet should be open all throughout the fermentation process. Dito kasi, dahil nga nagsisimula pa lang, tapos hindi pa kabisado, parang ginaya yung traditional na as in, andun lang siya, linagay lang lahat yung press beans, tapos later na lang inopen yung discharge outlet. So, kumbaga, nababad po talaga yung cacao beans. So, hindi niya gusto yun. Then, so with that also, we had dahil nga mahirap yung discharge, ang recommendation is also to increase the size of the holes at the bottom of the bean for better drainage of the liquefied pulp. And then the interval of stirring should as well be optimized. And then the second prototype is done by Maria Carmela Llobet. And with us as Ma'am Nila yung advisor niya and me as the program leader of the R&D. Okay, so ang orientation naman nito, so manual lang po ang steering, sa taas. So, parang manibela lang siya, yung steerer niya. Tapos yung orientation ng loading bin ay vertical naman. So yung nauna is horizontal. Yan. So, ang capacity niya is 40 to 50 kilograms. So, bakit ganon? Ito yung average na harvest ng ating mga cacao farmers. Kasi yung masyadong malaki. So, isinut namin ito. This was tailored fit or customized for small-scale farmers. Kasi halos based on yan products. 40 to 50 kilograms ng kanilang na-harvest at least a week. And the recovery is 88%, efficiency 87%. So dito, na-shorten na po talaga yung fermentation use. And the recovery is 65 ml per kilogram. So mababa. Actually, nakikita namin yung recovery is a function of the initial moisture content of the input fresh wet beans, fresh or wet beans. Tapos, yun, so na-optimize din niya at least na 10 rotation or maneuvers ang kailangan para ma-equalize yung temperature doon sa loob ng bean mass. So, meron yan mga tatlong positions ng temperature para ma-monitor. But so far, kahit naman yung una pala, I was not able to mention, kahit saan location inner, sa middle, and sa outer part ng bean mass, we were able to found out na insignificant naman yung location. So kahit parang uniform, we could say uniform yung distribution ng temperature within the bean mass. So mura lang siya that time, 2018, 20,000. So ang cost na to po, so hindi ito ngayon, yung cost na to na nakalagay dito, that was in 2018 for sure. Meron ng markup ito ngayon. And then, yung major recommendation niya dyan is to test the fermenter at full capacity kasi trinay niya to at na 40 kilograms lang. So merong buffer pa. May buffer pa siya. So titingnan natin dito yung fresh and fermented cacao beans. So sa figure A ay there is still enough space talaga to accommodate it. So walang problema kahit punong-puno siya. So sayang naman, So pwede siyang i-try for full capacity. So far it was not done yet. And then the third prototype. So actually ito yung main na prototype ng ating recent na development. So this was the thesis of Griselda Ochapa, just truly as the advisor. So, masyadong mataas yung ginamit itong horsepower. So later on, makita natin na hindi naman kailangan that much. Yun yata yung available yung motor that time during the testing. Okay, so weight niya is only about 108.5 kilograms. Capacity niya is the same with that of Carmela's weight, 40 to 50 kilograms. So the fermentation recovery is 89%, efficiency 95%, and fermentation duration is also 3 days. So ito, di ba, nakita natin, may deviations po talaga yung juice recovery. As mentioned, kailangan pa rin namin makita to. Kailangan pa rin pag-aralan. Kasi we see it sa function of the initial moisture content of the fresh beans. And that time, in 2019, the machine cost 48,000. Ito yung mga recommendations niya. Yung improve the visual monitoring system of the beans during the anaerobic phase of fermentation. Though, inayos na yan kasi based on prototype 1, nasa mention na nga ni Carl na kailangan nakikita but just the same, dapat yata mas malaki pa yung yung opening na yon para kitang-kita talaga yung cacao beans, especially during the anaerobic phase ng fermentation. And then also to test the fermenter at full capacity. Inayad yung kay Carmela na 40 kilograms lang. So, natakot na punuin. And then, ito na, yung employ automation on the control of steering operation or less operating supervision. Okay, so the method comprised of 3 phases. Matagal na ba ako? So, yung timer natin, please give me a cue. So, there are 3 phases, the design phase. This includes, of course, the research on prior studies, the design, the production of fabrication drawings using AutoCAD. Okay. Just showed you this. And then the second phase, of course, is the fabrication. Materials procurement, making sure that the loading bin is made up of food-grade stainless steel. And then comes the fabrication of the machine and, of course, setting up of the automation control system. So ito po yung ating automated cacao bean fermenter showing the major points. So during the testing phase, a bulk of good quality UF18, a high-grade Forastero variety, cacao bean samples were obtained, prepared. So we use here sa figure, we use here the the washer. Actually, this is a root crop washer. Trinay namin. So, okay naman siya. So, pwede din pala yun. Root crops and also for cacao pods. And then, from washing, it went to splitting or extraction of cacao beans. Para hindi ko makalimutan, kasi si ma'am ganyan, gumamit ng itak para ma-open, ma-split yung pads. So, meron ng 5 splitter. So, we have an ongoing study now. Yung sabi, na-mention nga ni Ma'am Nila kanina na paisa-isa lang. So, ito, paisa-isa din yung ginagawa ngayon. But, dire-diretso din siya. And then, kasama na din yung separation of the beads from the pads. So, yung first prototype with Bernadette ay manual yung pag-extract ng beans from the pads. Okay. And then, yan, pinasok natin sa ating fermenter. By the way, before that, we made sure na properly cleaned and sterilized or sanitized yung fermenter every other test. Okay, so test materials were checked, loaded in the equipment that allowed to ferment. And during this period, the temperature of the mass, of the bean mass, and pH of the liquefied pulp were monitored. So the first turning of the beans was done but after attaining the 47 centigrade temperature mark. And then the beans were left in the bean. The beans were left in the loading bean, until fully fermented and automatically and regularly turned or stirred every 6 hours. So the juice from the fermenting beans was collected and its volume was determined. So after fermentation, the bean mass was discharged from the machine and the fermentation recovery was obtained. Underwent drying. So ito dito, gumamit kami, we utilize sun drying that time kasi okay naman siya. And then, the dried fermenting beans, and then some samples were roasted for the sensory analysis for quality and sensory analysis such as bean color, odor, fermentation efficiency, and of course the bean count. We have 15 trained panelists to do the evaluation. So this one shows the stirrer. So ganon yung operation sa loob. So the stirring action provided adequate aeration to equalize the temperature of the bean mass. Walang sound. So sabi nga natin, very critical yung especially during the anaerobic phase. And ito, during the aerobic phase wherein the exothermic process now is initiated. So open po yung ating cover. So this release of heat is responsible for ensuring changes resulting in the development of chocolate flavor. And this one summarizes, table 1 summarizes the machine specifications and the output from the performance test. So it requires only one person to operate. So kahit babae can do the task. We use only 1 horsepower electric motor, and then we've tried it at 50 kilogram wet beans. Recovery was 89%, efficiency 97%, so 3 days duration ng fermentation. So ito, mas mataas-taas yung recovery of the liquefied juice, and the machine cost is 53,000. So yung automation system is roughly 5,000 lang. 48,000 yung wala yung automation system. Okay, so these are the sample pulp juice, also known as sweatings. So, Filmec, sa presentation ng Filmec, nakita natin, ang tawag nila dyan ay drippings. So, this is a white piece, liquid extracted from the wet cocoa beans. So, it contains predominantly minerals such as potassium, sodium, calcium, and magnesium. So, the fermentation of the sugars in the edible sweating or drippings may lead to the production of alcoholic and healthy drinks. So, marami nang na-develop na alcoholic and healthy drinks ang mga processors natin, such as soda, gin, and brandy, as well as premium wine and vinegar. So, ito yung monitoring and automation component system. This is installed and set to ensure that the stirrer shall automatically rotate at a desired temperature and time. So, yun, So, dapat, yung bean mass natin, dapat siya undisturbed while in anaerobic condition hanggang ma-reach niya yung 45 to 48 degrees Celsius, which is considered the optimum temperature per the Philippine national standards. So these are the quality indicators to make sure na adequately fermented na yung ating beans. So pag less than 45 kasi, 45 degrees Celsius, ganyan siya. Under fermented means ang puproduce natin. While pag more than 48 naman, either less than or yes, greater than 48 degrees Celsius ay over-fermented beans naman ang ating mapuproduce. Okay, so these are some of the coded samples for the cut test and sensory test and the sensory evaluation of the dried fermented beans. So the quality and sensory test, parang may cue na, mabilis. Ilang minutes na ba ako? Walang dito timer. Okay lang ba? So the quality and sensory test results showed that the produced dried fermented beans are at par with the export quality beans. And so, yun nga na-mention natin, we made use of the Philippine national standards developed by us. Even for the Pinnacle. A test of the dried fermented beans in determining the fermentation efficiency. So, dapat, ang kino-consider dyan to make sure na fermented talaga yung beans natin, dapat fully brown siya. Fully brown yung FB. Facebook fully brown. That's fully fermented. And then, PB or partly brown and PP or partly purple. Gusto ko to. Moderately fermented. So, dapat nandun lang siya. Siya yung basis natin in determining the fermentation efficiency. Yung iba, yung purple lang, yung segdamis, and all other categories, it lessens the fermentation efficiency. So, sabi ko nga kanina, the result or the produced beans, cacao beans, are at par with export quality fermented and sun-dried nuts. Ito yung naging point of comparison natin. We obtained export quality and traditional fermented and sun-dried beans to compare the output from the fermenter. So the developed optimized operating conditions were used in the preparation of the operator's manual to serve as an easy or reference guide to anyone who wanted to operate or use the fermenter. Yan. So may guide, ito yung operator's manual natin. So table 3 presents the cost and return analysis of the annual utilization of the fermenter in comparison to the traditional wooden box method. So the use of the machine could generate an ROI of 104%, a BCR of 2, and the investment can be recovered in just a year. And likewise, a partial budget analysis showed that using the machine will yield in-explain na yata nito ni Ma'am dapat positive yung incremental change in income. So this yielded a high net added benefit of 65,400 over the traditional wooden box method. Okay. So based on the results of the study, the following conclusions were derived. The design and develop automated cacao bean fermenter as outlined doon sa ating specification, machine specification. Fermenting efficiency, recovery are 97% and 89% recovery, and the fermentation duration was shortened to 3 days per batch. And then the fermenter significantly reduced the drudgery of turning the cacao beans during the fermentation process. And then the automation of the control of steering operation provided a less active supervision. So kahit matulog ka na, pwede kang matulog ng mahimbing habang ongoing yung fermentation. Unlike dun sa unang prototype na talagang kailangan mong bantayan ka to make sure na na-attain niya yung optimum condition, especially the temperature. And then this already allowed sanitary collection of cacao juice and liquefied allowed visual monitoring of the bean mass during the anaerobic phase, and of course the provision of caster wheels tapos may handle to make it gender friendly and allowed ease in the mobility of the equipment. Okay, as previously mentioned, the produced dried fermented beans were classified as top class dried cacao bean quality or grade 1A per the Philippine national standards. And then the cost and return and partial budget analysis both showed that the designed automated cacao bean fermenter is economically viable. And the following recommendations were formulated based on the results of the study. That is to conduct evaluation, and acceptability trials with the developed automated cacao bean fermenter and selected cacao farm. Sino kaya mag-take on ito? Upscale and customize the prototype to allow location-specific quantity of cacao bean fermentation. Okay. So, pwede siya. So, madali naman siya may upscale. And then, ito, binabantayan ito ng research division. No? So, we make sure that this is applied for copyright and patenting, not only of the equipment but also of the process. So we were able to optimize a certain process in the fermentation. And for the impact to the industry, this research opened a new avenue to more hygienic processing of cacao beans. So the equipment already improved the process, incorporating ito yung substantial load. We incorporate the recovery of the byproducts. This can be transformed into value-added products, thus enhancing the financial aspect of the commodity. And also, this development is also expected to reduce the drudgery of processing the commodity and provide a much controlled process that can enhance the quality of product. And so thank you. Thank you. So for any inquiries, please contact us through the email address of the department or my email address, and flash on the screen is my uh, home. So thank you so much.
And thank you very much for the profound discussion, Dr. Piscino. So, correction ko lang na si Dr. Anyate and Dr. Piscino are Professor 6 sa CBSUA. So, pardon for the error po.
Devoted.
So, kumustahin naman natin ang ating mga Facebook viewers dyan sa ating live. Nag-breakfast na ba kayo sa ating mga viewers dyan? I suggest na you should kasi marami pa tayong speakers na magpapartake ng kanilang topics. So, the design and development of an automated cacao bean fermenter have the potential to revolutionize the cacao processing industry. The precise control, consistency, and quality improvements offered by this technology benefits the cacao farmers, processors, and consumers, making it a valuable innovation in the world of cacao production. Now, to welcome our next speaker, he is a director of the University Review Center at Central Bicol State University of Agriculture-Pili, Camarines Sur, a coordinator of an accredited student organization, Office of Student Affairs and Services, an instructor 1 at Department of Agriculture and Biosystems Engineering, an advisor of the Philippine Society of Agricultural and Biosystems Engineers, a professional group, CBSUA chapter, College of Engineering and Food Science Student Council, and Sarong Banggi Organization International. And also, he is recently awarded as the 2023 Outstanding Young Agricultural and Biosystems Engineer of Bicol Region. So let us now welcome our next speaker to discuss the drying characteristics of cacao beans, Engineer Edgar Martin Y. de la Rama Jr.
Thank you so much for that was very long introduction. Thank you. So thank you so much also all the organizers and of course for inviting to one of your resources. And
Macau.
shout out also to our viewers via Facebook Live. Hello and good
Morning po.
So I will be presenting the optimization of the drying characteristics of cacao beans by response surface methodology. So this is a research by, of course, our very own Dr. Marife Alpicino and my classmate Pearl Caroline B. Valeros, who is also an agricultural and biosystems engineer. So why do we need to optimize and dry? So this is one of the most important processes in processes of cacao beans, which is drying, and of course optimization. So an optimization is the act of achieving the best possible result under given circumstances. So optimizing your product can mean many different things, and most of the agricultural commodities having an optimum condition of their drying process can minimize nutrient losses and maximize the shelf life of food products. So let me start with the short background of this study. So cacao is a perennial crop that yields several harvests annually and mature between 3 to 5 years, depending on its plant variety. So the cacao tree is grown in the tropics in a band between 10 to 20 degrees north-south of the equator, sometimes called the cocoa belt. So cacao beans are the source of cocoa solids and cocoa butter. So once these have been extracted, the beans can be processed into cocoa powder, chocolate, mole sauce, or chocolate-based cosmetics and spa treatments. So in response to the milestone in the cacao industry in the Philippines, the recognition of cacao as one of the high-value commercial crops in Philippine agriculture. So under the National Research and Development Agenda, for the post-harvest processing and enhancement of quality. The production of poor quality beans is due to improper processing practices and facilities. So in the Philippines, the roadmap of sustainable cacao has potential development opportunities wherein the target for production is 50,000 metric tons of quality cacao beans by the year 2025. Next slide. So having this, it come up with these objectives. So generally, the objective of the study is to determine the drying characteristics of cacao beans. So specifically, the study aims to, number one, determine the effect of the drying conditions to the drying rate, final moisture content, and overall acceptability of cacao beans. And next one, to determine the optimum drying condition of cacao beans, and two, develop a mathematical model that would best describe drying characteristics of cacao beans. So let us go back to the basics of drying cacao beans. So what is its importance? So an important step in cacao processing, as some of the reactions which produce good flavored cocoa are still proceeding during the drying process. So ideally, cacao should be dried over a 5 to 7 day period. This allows acids in the cacao to evaporate and to produce a low acid and high cocoa flavored product. If drying takes longer than 7 days, mold contamination can occur, and this leads to downgrading of the cocoa buyers, and cocoa and buyers, of course, will pay less for it. So the duration during which the beans are dried is very important. So if the beans dry too quickly, some of the chemical reactions that started in the fermentation process are interrupted, thereby making the beans taste acidic or bitter. So if the drying is too slow, the beans can develop fungus during the storage, and off flavors can develop inside the beans. So during the drying process, the beans lose nearly all of their moisture and half of their weight. So ideally, a dried bean should have 7% moisture content for the export market. So the present processes for drying cacao beans are sun-dried method and of course hot air drying method. However, sun-dried method unable to deliver large amounts of good quality cacao flavor, either because the process is inherently inefficient and cannot conveniently be scaled up. Also, hot air drying method, the beans produces high levels of acidity which impair the cocoa flavor produced. So with that, the drying characteristics of a crop should be significantly considered in establishing appropriate drying methods. So this is some of the facilities in and equipment for drying cacao beans. So we have here solar type drying equipment, and of course here there's another one. So in drying cacao beans, so one of methods is thin layer drying. So according to 𝐂𝐀𝐂 in 2002, as cited by Iyadolahina et al. In 2008, thin layer drying is the process of removal of water from a porous media by evaporation, in which excess drying air is passed through a thin layer of the material until the equilibrium moisture content, or the EMC, is reached. So moisture removal from an agricultural product depends on their drying temperature, velocity, and relative air humidity. So, and of course, variety and its maturity. Hence, various isolated and combined parameters are involved in moisture removal from a grain. So how about our method, which is the response surface methodology? So as cited by Ramos in 2000, response surface methodology is a tool essentially used in establishing the optimum operating condition of a product or determine a region of the total space of the factors in which a certain operations specifications are met. So the experimenter is often interested in what? So number one, finding a suitable approximating function for the purpose of predicting future response and determining what values of the independent variables are optimum as far as the response is concerned. So the optimization phase of the problem involves finding the values of the independent variables, so which is denoted by x1, x2, x3, which maximize the response. And F was a model fitted to the response surface generated by the experiment. So this model was a function of the test parameters, and it exists for every response. So in this case, this is the formula including those parameters that were gathered here in the study. So for statistical analysis, a second degree polynomial was used, and it is of the form where y is the dependent variable, then beta are the constants, and then x's are the independent variables. So before going to that, so an optimization process will be done. So these are the assumptions. So the three inputs, input factors denoted by x, will be closely controlled during the entire observation process and will be measured with negligible error. So that the dependent variables, which is denoted by y, will define the system and will be experimentally measured. So that there will be three mathematical functions that will describe the relationship between between responses, and the factors will be taken to be both quantitative and continuous. So the functions could be approximated by second order polynomial equations, so equations in the form of as shown in the presentation. So let's move on to the methodology of the study. So of course, this is based from the different literature reviews, and then after that we have the experimental method, statistical analysis, and the optimization and the validation, of course. So for the methodology, the thin layer drying method was used. So this is the schematic diagram of the dryer that was used in drying the cacao beans. So again, we have used the thin layer drying, which is suitable according to literature. So for the thin layer drying, this is the exponential model that was used. So as you can see here, the formula wherein the percent MR, the moisture ratio, wherein we get the difference of the moisture content at a time, or percent in dry basis. We have also the equilibrium moisture content, and the MO is the initial moisture content. So this is the difference, the ratio of the difference between the moisture content and then the equilibrium moisture content. So what are the drying parameters and what are the response variables that we have used? So as I have mentioned, so we have here the experimental designs that was used. We have the box Benken method. We have also the 3x3 functional factorial design with 15 drying runs. So what are the drying parameters that were considered? So for first one, we have the air drying temperature, wherein we have used what 40, 50, and 60 degrees Celsius. Next one is the air velocity. We have zero point 0.2, zero point 0.3, and zero point 0.4 meters per second. And of course, the loading capacity, wherein we have used 4, 8, and 12 kilogram per square meter. So the response variables that were considered in the study are the following. So we have the average drying rate, final moisture content, we have the pH, crude protein content, color, texture or brittleness, aroma, and of course the overall acceptability. So for the results and discussion of the study, we have the effects of the processing variables and the different response variables. So we have the drying air temperature affects the final moisture content. The air velocity affects the texture or the brittleness. Then we have the loading capacity. Of course, it affects the aroma. And they're all significant. And the drying air temperature, air velocity, and loading capacity do not affect the drying rate, color, and overall acceptability of cacao beans. So these are the developed prediction models for the different response variables that we have used. So as shown in the presentation, these are the different prediction models that were formulated. So, so here, so we have the color, aroma, texture, brittleness, and the overall acceptability. So for the optimization process of the thin layer drying of cacao beans, so we have limits of responses in determining the optimum drying conditions of cacao beans. So here we can see that the response variable that we have the final moisture content in percent dry basis. We have here the acceptable limits. We have also the drying rate, the pH, color, aroma, texture, and the overall acceptability. So we have based the results from the acceptable limits. So from the results that we have obtained, so comparing it to the acceptable limits, so we can see here that there are only uh, very what do you call this? Konti lang yung difference niya. So as you can see here, subtracting it from the actual values and the predicted values. So as you can see here, we have only very minimal differences. So from the response variables that we have used. So the contour plots for our response or the final percent moisture content as a function of the independent variables of cacao beans. So this is another one, the superimposed contour plots for 58 degrees and 0.3 meters per second. So superimposed contour plots of the response variables showing optimum region in the thin layer drying of cacao beans. So we have also here 58 degrees Celsius for 6 kilogram per cubic meter. So ito naman against the loading capacity. So for the first graph, we have here the temperature against the air velocity. So next we have the model that obtained. So we have here the optimum drying curve of cacao beans, the moisture ratio against the drying time. So in conclusion, we have the effects of the processing variables and the different response variables are the following. So we have the drying air temperature affects the final moisture content. Air velocity affects the texture or brittleness. The loading capacity affects the aroma. And the drying air temperature, air velocity, and the loading capacity do not affect the drying rate, pH, color, and overall acceptability of cacao beans. The optimum drying conditions, 58 degrees Celsius drying air temperature, 0.3 meters per second air velocity, and of course 6 kilogram per cubic meter loading capacity. So this is the optimum drying condition that we have obtained. So the drying curve of cacao beans is best described by the page model expressed as. So as you can see here in the presentation, the page model obtained. So the drying should be done in just 16 hours using a mechanical drying method instead of 3 to 7 days of traditional sun drying without quality deterioration of cacao beans. And for the recommendations, we have here to utilize the prediction of models developed in monitoring the drying process to ensure production of good quality cacao beans. Next one, adopt the drying conditions of 58 degrees Celsius for drying air temperature, 0.3 meters per second for air velocity, and 6 kilogram per cubic meter loading capacity as criteria for designing a mechanical dryer for cacao beans. So, and the last one, we have utilize the research results in crafting the drying protocol for cacao beans for you to have a better and reliable results. And that ends my presentation. Thank you so much po.
Okay, thank you very much, Engineer De La Rama, for that in-depth discourse. So the drying characteristics of cacao beans is of paramount importance in the cacao processing industry. Proper drying plays a critical role in preserving the quality of cacao beans and ensuring they are suitable for further processing. So, all right, for sure, punong-puno na agad ng knowledge and apprehension ang ating mga audience dyan sa ating Facebook Live. And you can also comment kung saang sulok kayo ng bansa para ma-acknowledge natin ang inyong virtual presence. At para rin ma-shoutout namin kayo kung saan kayo nanunood. Guys, you can comment it down sa ating comment section para ma-shoutout naman natin ang inyong presence sa ating event ngayon. Ayun, shout out kay Miss Erica Mayque Borbe from Bulan, Sorsogon. Hello po sa ating mga taga Bulan, Sorsogon. And also so Miss Julian Arroyo Orlina watching from Dubai. Hello sa ating mga kababayan sa Dubai. May nanonood rin. Watching from Eastern Samar, si Miss Juliana Rose Macavilla. Hello po, Ma'am Juliana. And also, Esmael Conteras from Lantapan, Bukidnon. Hello sa mga taga Bukidnon. Si Sir Johnny Ramik from Daet Camarines Opag, Camarines Sur. Norte. Camarines Norte, I mean. Also, si Miss Dalen Ann Matnog, Hermosillo, watching from Rosario Agusan. Also, si Miss Jana Mara Manuta Lago, watching from Cagayan de Oro. Hello po sa mga taga Cagayan de Oro. All right. Meron din mga taga Kamsur dyan sa Labo. Ay, Gainza, Camarines Sur. Loob, Gainza, Camarines Sur. So, remind ko ng ilip kayo na i-comment nyo sa ating comment section ang inyong mga katanungan and sasagutin ng ating speakers yan shortly. And also, kung hindi pa kayo nakaka-fill out ng ating attendance form, maaari po lamang i-click ang link na nakapin sa ating comment section because e-certificates provided if you successfully fill out our evaluation form to be posted on the latter part of our session. Okay, now, ready na ba ang ating viewers for our next speaker? Ayan, meron din from Davao, from Cavite State University, and of course, from CBSUA-Pili, Camarines Sur. And Gumaka, Quezon. Ayan. Okay, now moving on sa ating fourth speaker, to welcome our fourth speaker to discuss the design, fabrication, and performance testing of CBSUA Fluid Bed Cacao Roaster. He is an Engineer 1 at Agricultural Training Institute Regional Training Center 5 at ATI Bicol, a former instructor at Camarines Norte State College, Labo Campus, a research assistant at Research Division, Central Bicol State University of Agriculture-Pili Camarines Sur, a senior test engineer at HVC and a member of the Philippine Society of Agricultural and Biosystems Engineers Professional Group. So now please welcome Engineer John Smith Arcilia. Hello po, Engineer Arcilia. Ayan. Hello sir, good morning po.
Morning. Wait lang. Let me share my presentation.
Sure po sir, go.
Nakikita na po?
Yes po, okay na po.
Ayan, okay. So, good morning everyone. Sa lahat ng mga manonood natin sa Facebook Live and syempre sa mga students from CBSUA, good morning everyone. Sa mga professors natin dyan sa CBSUA na nanonood ngayon and also yung mga nag-present din, good morning po. So, ayan, today, papakilala mo na ako. I'm Engineer John Smith Arcilia. So, thank you po sa nag-introduce sa akin. So, currently, I am employed at ATI Bicol as an Engineer 1 under the National Livestock Program and CDMS or Career Development Management section. So, yun po. During itong college days. So ito yung thesis ko, Design, Fabrication, and Performance Testing of CBSUA Fluid Bed Cacao Roaster Prototype 2. So ang advisor ko po niyan is si Engineer Julius De Villa. So yan, siya po ang nakaisip nung fluid bed. So bakit nga ba dito magsisimula muna tayo dito sa title niya mismo na Fluid Bed Cacao Roaster. Bakit ba siya tinawag na fluid bed? So, technically, kapag sinabi nating fluid, it doesn't refer to sa liquid lang. Diba? Kapag sinabi nating fluid, kasama yan yung sa gas and liquid. So ngayon, ipapakita ko sa inyo yung design ng machine kung bakit ba siya tinawag na fluid bed cacao roaster. So yun, na-discuss naman ng mga previous presenter natin yung definition and also yung background ng cacao. So, i-skip na natin yan since medyo sobrang iksi lang ng oras na binigay sa atin. And also, this presentation is summary na lang talaga siya. As in, sinamarize ko na lang, hindi ko na inisa-isa per section yung presentation ko. So ito, meron tayong three varieties of cacao. We have the Forastero, Criollo, and Trinitario, which was discussed earlier. Then, cacao tree, 70 fruits annually. Nagproproduce siya ng 20 to 60 seeds each pod. Then, sa application, discuss na rin ni Sir Ed kanina na ginagamit siya for food, for pharmaceuticals, for cosmetics. So, sobrang daming use ng cacao. Ngayon, yun yung nag-arise na problem sa atin. Kasi sobrang daming applications ng cacao natin and based sa data, so that is na from DA 2016, wala pa tayong substitute for the cacao. Then, sobrang taas ng demand, ang baba naman ng supply. Ngayon, sa production, hindi na natin siya masyado finokusan din sa may thesis natin. So, ang ginawa na lang namin ng advisor ko, which is si Engineer Julius, ang ginawa namin is mabawasan na lang yung losses during the post-production of the cacao. Ngayon, ang alam ko, meron na tayong substitute for the cacao, which is the jackfruit seeds. Yan. Meron na mga researches na tinatry na gamitin for substitute ang jackfruit seeds, yung sa langka, buto ng langka. So yun, tinatry nilang i-integrate sa chocolate production and also sa iba pang production na pwedeng alternative para din sa cacao. So yun, balik tayo. So yun, sobrang baba nung supply pero ang taas ng demand. Kaya sa thesis na ginawa namin, which is the cacao roaster, gagawin na lang natin is babawasan na lang natin yung mga losses and mapataas yung efficiency nung cacao production natin and also yung quality din. Kasi sa cacao natin, meron tayong mga losses kapag nasunog na. Like, hindi na siya mapapakinabangan. I know, napapakinabangan pa naman yung mga burned cacao natin sa roasting sa mga bitter taste na chocolate. So, maraming mga may hilig din naman, di ba, sa mga mapapait na chocolate. So, yun. Ang sa production ng roasted cacao beans, yun yung gusto nating ayusin, which is yung quality of the cacao beans, roasted cacao beans, and also yung mabawasan natin yung losses. So ngayon, ano ba yung pinakang objectives ng study natin, which is yung sa design, fabrication, and performance testing of the CBSUA fluid bed cacao roaster. So ang gagawin lang natin is modify lang natin yung existing na prototype 1 na fluid bed cacao roaster and also to test the performance of the machine. Specifically, yun, magpa-fabricate tayo, magde-design tayo, magpa-fabricate tayo ng bagong design ng cacao roaster. Then, ite-test natin yung performance of the machine. Then, i-determine natin yung quality ng roasted cacao beans once na nag-undergo na siya dun sa machine natin. So, ngayon, punta muna tayo dun sa may flowchart in cacao production. Sa production, meron tayong harvesting. Then, pagkatapos natin yung harvest, dun na papasok yung thesis nila, research nila Ma'am Nila, which is yung sa pod breaking with Engineer Badet. Then after naman nung pod breaking, meron na tayong fermentation. So yun na yung research naman nila Lala, ni Engineer Lala, ni Engineer Galvez, ni Engineer Ochavo, then with their advisor, Ma'am Mafe Pisinos. So yun, doon na papasok yung sa fermentation. Then after fermentation, papasok naman tayo dun sa may drying, which was discussed by Sir Ed kanina. Then after nun, para malinis natin, bago tayo makapag-roast, syempre kailangan muna natin isort yung cacao beans natin or yung dried cacao beans natin. Then tsaka na tayo, doon na papasok yung thesis ko na cacao roaster. So ito, cacao harvesting, 5 to 6 months to mature from pollination. Then 75% of the cacao pod is nagmamature, nag-change ng color due sa maturity. Then, skip na natin yan. Post-harvest, ito na yung sa pod breaking. Then, papasok na din dyan yung research nila Ma'am Nila and ni Engineer Badet. Then after nung sa pod breaking natin, yan, meron tayong yung sa traditional way of fermentation, which is the wooden box, na nagre-range to 5 to 6 days, 5 to 7 days ang fermentation process niya. Pero because of the technology or mechanization, na-shorten natin yung um, span nung pag-ferment natin. So, from 5 to 6 days or 5 to 7 days, na-shorten natin siya to 3 days. So, yan na yung machine na fermenter nila Engineer Ochavo and with her advisor, Dr. Pisino. Then, in-automate namin last 2020. Diyan na. Instead na manual yung pag-mix natin, so meron na tayong automated na fermenter. Then after fermentation, syempre i-dry natin. Sabi ni Sir Ed kanina, 7% na moisture content, good for export. Then pero sa dry beans natin, we can use the 5 to 7.5% na moisture content para naman sa roasting of the cacao. So meron tayong 3 ways of drying. Meron tayong sun drying, ibabalad lang natin through the sun. Meron tayong solar dryer, ito, kung nakikita nyo ito. Gagamit tayo niyan. Then combined mechanical and solar dryer. So yun yung 3 ways ng pag-dry natin. Then after drying, isosort na natin, alisin natin yung mga impurities, yung mga walang laman ng mga cacao kasi syempre makaka-affect din siya dun sa pag-test natin. Then after sorting, yan na. Meron tayong traditional way of roasting ng cacao, which is the pagsanlag. So ang gagawin lang natin, meron tayong pan, meron tayong spatula, then sasanlagin lang natin siya. As in, para ka lang luluto. So ganun. Ang ano lang dito, hindi naman sa ano, ang cons lang nito ay syempre yung sa labor natin and also yung sa pag-roast mismo ng cacao. Kasi sa cacao natin, might be syempre dahil sa addictive aroma of the cacao, ang nangyayari habang alam nyo, yung habang nagsasanlag kayo, naaamoy nyo yung amoy nung roasted cacao beans. Then, sige ka lang, as in roast ka lang, ganyan-ganyan, hanggang sa hindi mo na napapansin, medyo totong na pala yung cacao mo. So, yun yung addictive aroma of the cacao beans. So, yun, sa ano kasi, syempre, sa pagkanta ko ng thesis, meron akong manual, then meron tayong, ito na, mechanical, yung paggamit ng machine. So, habang pig-roast ko itong cacao, and also, meron naman akong expert din sa cacao na nag-roast, itong manual roasting. Medyo, addictive na daw talaga yung amoy nung roasted cacao beans. Kaya, minsan daw, natututungan talaga siya. Kaya nagkakaroon siya ng burnt color, burnt odor nung cacao beans, which is, kailangan natin siya i-separate sa good roasted cacao beans para syempre yung quality nung maproproduce nating chocolate kung nasa chocolate industry tayo. So yun, kailangan natin sa yung burnt taste, yung burnt odor. So yun. Yun yung parang cons dun sa paggamit dun sa lag. Now, doon na papasok yung machine natin na fluid bed cacao roaster. So kung nakikita niyo dito, sa machine na ito, meron tayong 5 main components of the fluid bed cacao roaster. So meron tayong roasting drum. Ito po yung roasting drum natin. Dito natin nilalagay yung 5 kilograms of the cacao beans, dried cacao beans. Then, dito sa baba ng roasting drum natin, meron tayong heating chamber, which enclosed the nichrome wire. So, yung nichrome wire po natin, yun na po yung magbibigay ng heat dun sa cacao natin. Then, meron tayong blower. So, itong blower naman po natin, syempre, with the use of the air, which is 60 cubic meter per hour na volumetric flow rate. Then dun sa 16 cubic meter per hour na volumetric flow rate natin, dadaan siya dito sa heating chamber natin. Then dito sa may heating chamber natin, pag dumaan na dito yung airflow rate, yung airflow natin, paglabas niya dito sa heating chamber, mainit na yung yung gas natin or yung air natin. Then syempre, mainit na yung air natin, yun na mismo yung mag-roast nung cacao natin. Ngayon, paano yung mixture nung cacao natin? Kasi kung nakikita nyo dito, sa components natin, wala tayong stirrer. Ang mechanism ng fluid bed cacao roaster natin, that's why it is called fluid bed, dahil yung heated air natin, yun na mismo yung magluluto ng cacao natin, as well as siya na rin yung magmi-mix nung dried cacao beans natin. So, ang mechanism niyan, nandito yung, kung nakikita nyo yung kamay ko, I'm not sure, nandito yung cacao natin. Then, because of the concentrated airflow dito sa tube natin, sa heating chamber natin, pataas siya. So, yung nasa middle part, nung dried cacao beans natin, ipupush ng heated air natin. Then, yung nasa gilid na cacao beans, dried cacao beans, bababa naman siya. So, habang bumababa, yung dried cacao beans natin sa may palibot ng roasting drum natin, hello? So, habang yung roasting drum natin, yung nasa palibot ng roasting drum natin na dried cacao beans, magfo-fall siya. Bababa siya dun sa angle ng roasting drum natin, yung conical part. Then, once na nag-slide down na yung dried cacao beans natin, syempre, pupunta siya dun sa may baba. Then, continuous na yung yung mechanism ng fluid bed cacao roaster natin. So, yun po yung mechanism, kaya siya tinawag na fluid bed cacao roaster. Aside from providing heat dun sa dried cacao beans natin, also it serves as the stirrer of the of the dried cacao beans. So ganun lang yung magiging mechanism niya sa roasting drum natin because of the heated air. So syempre meron tayong 2 horsepower na electric motor and yung main frame na nag-hold dun sa lahat ng components ng machine natin. So ito yung specification nung machine natin. So, isa lang ang kailangan natin na labor. So, siya lang yung taga-load and unload nung dried cacao beans natin. Then, ang power consumption natin is 3.9 kilowatts per hour. Ang total weight po ng machine ay 106 kilograms na merong dimensions na 142 centimeter height or 1.42 meters. Yung length naman natin ay 111.68 cm or 1.11 meters. Then, ang total width naman natin ay 36.2 cm. Ang roasting time natin ay 2.5 hours. Yan ay yung optimum based dun sa three parameters natin. Mamaya, i-discuss ko kung paano nakapag-come up dito sa final machine specifications. Then, meron tayong roasting capacity of 2 kilograms per hour. Yung roasting drum natin, ang maximum niya or ang optimum capacity niya ay 5 kilograms. Meron pa naman tayong space doon para sa kapag binuga na yung cacao natin. Pero, yun, this machine was designed at 5 kilograms capacity of the cacao beans. Then, ang roasting efficiency natin ay 87%. So now, ito yung ano natin, design. Meron tayong, ito, hindi ko ito napakita kanina. Ito yung cover natin. So, perforated yung cover natin para yung heated air, hindi lang siya sa loob ng ng roasting drum natin. Siyempre, kailangan din yan ng exhaust. So, papalabas din siya. So, yun. And ito yung different parameters natin. Meron tayong roasting time duration. So, yung machine po natin, tinest po natin siya at 3 different roasting time duration. So, para malaman natin yung optimum na roasting capacity and efficiency nung machine. So ngayon, meron tayong 1.5 hour na roasting time duration, meron tayong 2 hours na roasting time duration, and 2.5 hours na roasting time duration. Same capacity, which is 5 kilograms. So kukunin lang natin at 1.5 roasting time durations, ang roasting recovery natin ay 98%. Ang roasting capacity naman natin ay 3.3 kilometers, pero mataas ang capacity niya, mataas ang recovery niya. Ang problema is yung efficiency, which is 52% lang. Why? Yung 52% na yan, yun lang yung roasted cacao beans na nabalatan natin. Kasi paano ba natin masasabi na roast din ang na roast na yung cacao natin? So dapat ang cacao natin ay easy to break na yung balat mismo ng cacao. So yun, yung mga hindi na nabalatan na cacao, ibig sabihin hindi pa siya naro-roast na maray. Or hindi pa siya naro-roast ng maayos. Kaya yung na-recover lang natin is total recover natin is 90%, pero yung balatan lang natin or yung nakawa natin na roasted cacao beans ay 52% lang. Then at 2 hours naman, mataas ang capacity natin, which is 2.5 kilograms per hour. Mataas din ang recovery natin, which is 98%. Pero yung efficiency natin ay 68.6% lang. So ngayon, dun na papasok itong 2.5 na roasting time durations. Ang roasting capacity natin is 2 kilograms per hour. Ang roasting recovery natin ay 97.4%. Ang roasting efficiency naman natin ay 87%. Ibig sabihin, sobrang dami ng na-roast natin na cacao beans at 2.5 or 2.5 hours na roasting time duration. So, dun sa tatlong parameters na yun, alin yung pipiliin natin na best time roasting time duration? Syempre, dun tayo titingin sa efficiency nung cacao natin or nung machine natin, which is nakapag-come up tayo dun sa 87% na roasting time duration at 2.5 roasting time duration. Then, in terms naman dun sa quality nung cacao natin, di ba, ang first na objective natin is to design and fabricate the CBS fluid bed cacao roaster. Okay na design na and also na fabricate na. Then second is to test the efficiency of the machine. So nakuha na natin at 2.5 roasting time duration. Nakakuha tayo ng 87% na efficiency. Then, doon naman tayo sa third objective natin, which is the quality of the cacao beans. So, ito yung hedonic scale natin para malaman natin yung quality, yung quality nung cacao natin, kung nagustuhan ba siya ng consumer natin. So, meron tayong like extremely, ito yung mga categories natin, like extremely, like very much, like moderate, like slightly, neither like or dislike, dislike slightly, dislike moderately, dislike very much, and dislike extremely. So meron tayong sensory score dyan, corresponding dun sa category natin. Then aside dun sa hedonic scale natin, meron tayong descriptive terms in classifying the sensory characteristic of the roasted cacao beans. So meron tayong 4 na category, which are the appearance, aroma, flavor, and yung texture. So dun sa appearance natin, meron tayong 4. So meron tayong, makikita natin yan based sa naked eye natin. Brown color, reddish brown color, dark brown color, or burn color. So, nandito naman sa definitions natin kung paano natin makakategorize yung sa appearance niya, kung sa brown ba siya, reddish brown, dark brown, or burn color. Sa aroma naman, meron tayong mild cocoa smell. So, naamoy pa rin naman natin yung cacao smell niya, pero not too strong. Then, meron naman tayo strong cacao smell. So, yan yung amoy na talaga natin yung cacao. Then, yung burn color naman, yung tutong na amoy nung cacao. Sa flavor naman natin, slight bitter taste dahil ang cacao naman natin ay mapait man talaga. Pero dito sa flavor, matitikman natin yung roasted cacao beans at less bitter taste. Then meron naman tayong bitter taste. Then meron naman tayong burnt taste or yung tutong na. Then sa texture naman, meron tayong firmness and fracturability. Sa firmness, kailangan nyo pa ng puwersa para buksan yung or para matanggal yung balat mismo ng cacao nibs natin. So, yun yung firmness. Sa fracturability naman, sobrang dali lang balatan yung cacao beans natin or yung cacao nib natin. So, yun yung descriptive terms para dun sa sensory evaluation natin. So, sa pag-conduct ng sensory evaluations, meron akong 10 panelists na kinuha from the food tech. So, siyam po doon ay mga estudyante and isa po doon ay expert sa cacao industry. So, yun. Based dun sa result ng sensory evaluation natin, ito yung lumabas sa hedonic scale natin. So, at 1.5 roasting time durations, pumapasok lang sa 6.75 na sa hedonic scale or din sa may category natin, yung roasted cacao beans natin at 1.5 roasting time duration. Ang 6.75 ay pumapasok sa like slightly and like moderate. Sa ano naman natin, sa 2 hours and 2.5 hours naman natin, nagpo-fall siya dun sa like moderate and like very much. So, ibig sabihin, pasok yung roasted cacao, yung quality ng roasted cacao beans natin at 2 hours and 2.5 hours na roasting time duration. So, doon na lang tayo papasok sa 2 and 2.5. But, kino-consider din natin yung efficiency ng machine, which is mas mataas yung nakuha natin na efficiency sa 2.5, which is 87%. That's why the optimum use so far of the machine is at 2.5 roasting time duration, which is 87% roasting efficiency. And in terms naman din sa characterization ng roasted cacao beans natin, so kung nakikita nyo, yung sa 1.5 puro 1, then yung number 2 naman natin, 2.121, and yung 2.5 halos 2. Saan ba nakuha yung 1 and 2 na yan? Balik ulit po tayo dito sa descriptive terms natin. So kung nakikita nyo po dito, palubat na. So kung nakikita nyo po dito, meron tayong 4, di ba, sa appearance na category. So yung brown color natin is 1, reddish brown natin, 2, 3, 4, then 1, 2, 3, 1, 2, 3, and 1, 2. Yung 2.5 na roasting time durations natin, lahat tama, di ba, 2? So yung appearance nung roasted cacao beans natin at 2.5 roasting time duration, pumapasok siya dun sa reddish brown color, which is good para dun sa cacao natin, sa roasted cacao natin. Then for the aroma naman, strong cacao smell. So yun na yung best na aroma para dun sa cacao natin. So pasok na naman siya. Sa flavor naman natin, bitter taste. So ibig sabihin, nakuha din natin yung bitter taste similar to caffeine ng cacao natin. Then sa texture naman natin, pupasok siya dun sa fracturability or sobrang dali lang balatan nung cacao natin. So, ibig sabihin, in terms of the quality of the cacao, makukuha talaga natin siya at 2.5 roasting time duration. So, yun. Nakuha na natin yung tatlong na-meet na natin yung tatlong objectives nung research natin. So first is yung design and fabrication. Then yung second naman natin is to test the machine, the performance of the machine, and yung quality ng cacao beans natin. So at different parameters, ito na yung pinakang conclusion. So the CBSUA Fluid Bed Cacao Roaster Prototype 2 has a roasting efficiency of 87%, roasting recovery of 97.4%, and roasting capacity of 2 kilograms per hour at a roasting duration of 2.5 roasting 2.5 hours or 2.5 hours. Then sa prototype 2 naman natin, it can produce 11.9 kilograms of roasted cacao beans per day. So yung 8 hours na pag roast natin, so ayan yung kaya niyang i-produce 11.9 kilograms of roasted cacao beans per day. Then the roasted cacao beans at 2.5 hours were scaled 7.75 or in between the like very much and like moderate in hedonic scale and were categorized or characterized to have a combination of reddish brown color, strong cacao smell, bitter taste, and easily broken or rupture. So lahat nung quality nung cacao na hinanap natin for the chocolate production ay passed, or yung roasted cacao beans natin at 2.5 hours is past the quality checking nung roasted cacao beans natin. So ano yung recommendations natin? So to improve the heater, these are the recommendations of the researcher, which is me. Improve the heater and test the machine at different higher temperature. Kasi meron akong mga nabasang researches na gumagamit sila ng 130 degrees Celsius, pero ang ginamit ko lang po kasi na temperature dito ay 100 degrees Celsius. Then increase the airflow rate of the blower para mas yung mixture nung roasted or yung dried cacao beans natin, mas maganda yung rotation niya. Kasi baka dahil doon sa heater and sa may blower, kaya ang efficiency lang ng roasted cacao beans ng fluid bed cacao roaster natin ay 87% lang. So pwede natin na i-increase yung temperature nung machine natin, or we can increase the airflow rate of the blower. Then since yung blower natin ay designed lang po siya, pina-fabricate ko lang din po yan. So medyo maingay pa yung blower natin. So try natin na mag-install ng silencer din sa may blower to decrease the noise level. Siyempre, kung sa testing of the machine, so di ba sa Amtech, pinapatest natin yung machine natin, and kinukuha rin nila yung noise level nung machine natin. So kung dun sa noise level nung machine natin, bagsak pa ito dahil dun sa sobrang ingay nga nung blower. So I suggest na kung merong mga gustong ipagpatuloy yung research, so pwedeng lagyan natin ng silencer yung blower. So yun lang.
All right, thank you very much for the
Thank you.
comprehensive
So kung may mga
deliberation.
questions po.
Okay po. On the latter part pa po, ang ating Q&A portion.
Okay.
So mag-standby na lang.
Sige po.
Okay. So thank you very
everyone.
much. Thank you po, sir, for the comprehensive deliberation of the topic, Engineer Arcelia. So the design, fabrication, and performance testing of the CBSUA Fluid Bed Cacao Roaster represent a significant advancement in cacao processing technology. This innovative equipment offers a range of benefits, including improved quality, energy efficiency, and sustainability. And it has the potential to positively impact cacao farmers and the overall cacao industry. Now, moving on to our last speaker. So, nasa last speaker na tayo. Malapit na tayong matapos. So, he will discuss about the evaluation of cacao pod husk for the production of charcoal briquettes. He passed the Agricultural and Biosystems Engineering licensure exams on September 2023. He obtained a national certificate in rice machinery operation, Ryden International Technological Institute, and a graduate of Central Bicol State University of Agriculture. Let us now welcome Engineer Evan A. Plamiano. Good morning po, Engineer.
So, good morning. Thank you, Miss Nicole. So, sa lahat po ng viewers, good morning po sa inyong lahat. So, kanina po, sa mga previous speaker, diniscuss na po yung mga technologies sa pag-produce ng cacao. So, sa moment po ito, ako naman po ay magdi-discuss about naman po sa waste utilization naman po nitong byproducts ng cacao processing. So, ang study ko po is evaluation of cacao pod husk for the production of charcoal briquettes. Ang thesis advisor ko po dito is si Ma'am Jennifer M. Iwonya. So, shout out to Ma'am. And bago po tayo dumako doon sa main discussion, gusto ko lamang po magbigay ng brief summary ng studying ito. So, ang general objective po ng studying ito is makaproduce po tayo ng charcoal briquettes gamit po itong cacao pod husk. Also, gamit din po yung dalawang indigenous binders natin na fresh cow manure and clay. So, ito po ay may 6 treatments, tigta-3 po kada binder. So, 3 po para sa fresh cow manure and 3 naman po para sa clay. And para matest po yung quality or ma-evaluate natin yung quality ng ating charcoal briquettes, dumaan po ito sa iba't ibang uri ng test. So, naandyan po yung degree of friability, naandyan din po yung back density, yung proximate analysis, heating value, and also yung ating water boiling test. So, after natin sa test, kinuha din natin yung ating economic viability nitong ating charcoal briquettes. So, next po. So, kanina na-discuss naman po yung cacao. So, all about cacao, na-discuss na po. So, ngayon, punta na po tayo dito sa ating cacao pod husk. So, ano nga ba itong cacao pod husk? So, ang cacao pod husk is a byproduct of cacao processing. So, ito po yung waste na mapuproduce natin after po nating makuha yung main product, which is yung beans natin. So, sabi po dito, 52 to 76% of cacao pod is yung balat. So, ibig sabihin po, sa isang cacao, so almost 3/4 po nito is napupunta lang po doon sa waste, sa balat. And sabi ni dito, every ton of dry cacao beans is equivalent to 10 tons of cacao pod husk. So, para makaproduce po tayo ng 1 toneladang dried beans, ang kaakibat po nito na waste is 10 tons. So, napakaraming waste po ang na-generate po dito sa cacao processing, yes. Kaya po, mas maganda po na at least magamit po natin itong waste na to. Next po. Next po. So, yun. So, dako na po tayo dito sa characteristic of cacao pod husks. So, naglagay po ako dito ng 3 characteristics. So, una ang cacao pod husk is renewable. Renewable po siya kasi every year or every season naman, mayroon tayong production ng cacao. So, yung supply natin ng cacao pod husk is hindi nawawala. So, number 2 is yung high heating value. So, ito po yung isang reason kung bakit maganda po siyang gawin as charcoal briquettes. Kasi po ang charcoal briquettes is ginagamit po siya as a cooking fuel. Yun po yung main source, yun po yung main use ng charcoal briquettes. So since na mataas po yung heating value niya, suitable po siya as charcoal briquettes. Tapos pangatlo po is yung high moisture content niya. Ito naman po yung downside nitong charcoal briquette, ay itong cacao pod husk as charcoal briquettes kasi po medyo mataas po talaga yung moisture content nitong nitong cacao pod husk rather. So during po nung nagkanda ako ng study, kinuha ko po yung moisture content ng cacao pod husk and ang nakuha ko pong result is almost 78% po yung moisture content ng cacao pod husk. So yun po. Next po. So yun. So nalaman na natin kung ano itong cacao pod husk. So yung characteristics niya. So ngayon, alamin naman natin kung ano nga ba itong charcoal briquettes. So by definition, it is a compacted mass of fuel material made from a mixture of charcoal fines, binder, and molded under pressure. So, para po makabuo tayo ng charcoal briquettes, kailangan po natin ng 4 na elemento. So, una ang kailangan natin is yung charcoal fines. So, in my case po, ang ginamit ko pong charcoal fines is yung ating cacao pod husk nga po. Tapos, pangalawa po, yung ating binder. So, kailangan po natin ng binder sa charcoal briquettes. Tapos, ang ginamit ko po dito, 2 uri ng binder, which is yung fresh cow manure at saka yung clay. Pangatlo is yung ating tubig. At ang pang-apat naman is yung ating pressure or yung ating charcoal briquetting press. So, yun po. Next po. So, yan. So, saan nga ba ginagamit ang charcoal briquettes? So, as I mentioned earlier, ang charcoal briquettes, pinaka-common use niya po is for cooking po. So, yung nasa picture po, yan po yung actual charcoal briquettes na na-produce ko during po sa study. So, yan. And yan naman po yung sa gilid, nasa right, yan po yung test ko, water boiling test po. So, yan. Next po. So, yun. So, alamin naman natin kung ano itong mga characteristic ng charcoal briquettes. So, ang charcoal briquettes, less smoke when used. So, minimal po ang smoke ng charcoal briquettes kasi po, yung ating raw materials is dumaan na po sa carbonization process and doon pa lamang po is natanggal na po yung volatile combustible matters niya, kaya, o yung mga usok niya, doon pa lang po natanggal na. So, high heating value din po siya since compacted po yung ating charcoal briquettes, masasabi natin na high heating value. Marami pong heat na mapoproduce siya. And also, siya po ay less messy. Less messy kasi ang charcoal briquettes, kung makikita natin, is uniform yung sizes niya. So, pwede natin siyang ipack, ilagay sa isang lagayan, pagpatong-patungin, at ilagay sa isang sulok. So, mamamaximize natin yung space natin. Next po. So, yun. So, nalaman na natin kung anong CPH or cacao pod husk, yung charcoal briquettes. Ngayon, alamin naman natin yung process kung paano tayo makabuo nitong briquettes. So, naglagay po ako dito ng 6 na process na ginawa ko during the conduct of the study. So, ang number 1 ko po is yung collection and preparation of raw materials. Pangalawa po is yung carbonization process. Pangatlo is charcoal pulverizing. Pang-apat is weighing and mixing. Pang-5, briquetting and molding. At pang-6 is yung drying natin. So, isa-isahin natin to. Next po. So, yun. So, ang unang step is yung collection and preparation of raw materials. So, sa collection, so dito, ang gagawin natin dito is magko-collect tayo ng ating cacao pod husk. So, sa study ko po, kumuha po tayo ng cacao pod husk is galing po yun kay Ma'am Mafe. Kasi po, during po nung nag-conduct ako, si Ma'am Mafe din po is nagka-conduct din po ng isang study and ang ginagamit niya po is yung beans mismo and sakto po nagkataon na nagkakandak din po ako. Kaya yung cacao pod husk niya po is ako po yung nag-utilize. Kaya thank you po, Ma'am Mafe. And after nating makakolect ng sample, kailangan natin itong biyakin at least kasi once na pag nag-undergo tayo ng drying na di natin biniyak, medyo matatagalan po tayo. Kaya ang sunod nito is drying na. So next po. So after natin mag-collect, we have the drying. So sa drying, nung nagkandak ako is inabot po ako ng 3 to 4 days sun drying. Pero itong sun drying na ito is depende po yan sa panahon. So since na sabi ko kanina na medyo mataas po nga yung ating moisture content ng cacao pod husk, so almost 78%. So medyo matatagalan po talaga yung ating drying. So ang main goal ng drying pala is ma-reduce natin yung moisture content up to 18% or below. So yun. So dapat mas below yung ating moisture content sa 18% kasi upang mas madali natin ma-carbonize yung ating cacao pod husk and also less energy na po ang gagamitin natin. So, next po. So yun. So next step is a carbonization process. It's a slow pyrolysis process in which the production of charcoal or char is the primary goal. So ang main objective lang naman ng carbonization natin is makaproduce tayo ng charcoal. So later i-discuss ko po isa-isa yung ating carbonization process. Tapos itong cacao po pala is may charcoal yield na 31.7%. So ano po itong charcoal yield? Ang charcoal yield po, ito po yung percentage na yung na-harvest natin na charcoal na over po doon sa nilagay nating cacao pod husk sa ating drum carbonizer. So next po. So yan. Ito na po yung process sa pagka-carbonize. So ang una nating gagawin is cleaning and preparation of drum carbonizer. So yung carbonizer po palang iyan, yan po yung drum carbonizer ng Naga City Sanitary Landfill. Yan din po yung ginagamit nila sa pagka-carbonize ng kanilang mga biomass na ginagamit din nila as charcoal briquettes. So yan, lilinisin po natin yan kasi para po makaiwas tayong madagdagan ng ibang residue yung ating cacao pod husk or dapat pure po talagang cacao pod husk ang ating magamit. So next po. So yan. So after nating malinis, so ang sunod naman natin gagawin is ilalagay na natin yung ating cacao pod husk dun po sa gilid ng ating drum carbonizer. So kung makikita mo po natin, may parang rolled screen po yan sa gitna. So mamaya po sasabihin ko po kung ano ang use niyan. So yon, ilalagay lang po natin dyan yung ating cacao pod husk. So next po. Yeah. So dito na po tayo sa kindling and continuous burning. So yun. Gaya nga po ng sinabi ko kanina, yung rolled screen na yun po ay magsisilbing guide lamang po para po yung ating ignition or yung sindi is magsimula po sa ilalim para po uniform yung ating carbonized materials. So yan, after nating magsindi, so hahayaan natin siyang magliyab or mag-apoy. Almost nung time po is mga 1 to 2 hours po yan na paghihintay hanggang po sa maging ganyan po sa pangalawang picture sa right po. Nagliliyab na po siya. Pero dito po sa part na to, hindi po natin siya aantayin na maging abo. Kasi pag naging abo po siya, magiging useless po yung carbonization. So, pag nakita natin na baga na po siya, yung baga na po, saka na po natin siya tatakpan. At dito na po papasok yung ating cooling. So, next po. So, yun. Cooling process. Sa cooling process pala, so, after natin siyang matakpan, so, i-cool down natin siya for 1 day. So, 24 hours. So, kung halimbawa ngayon tayo nag-carbonize, kinabukasan po, harvest na po yan. So, next po. Yan. So, last stage po ng carbonization is yung harvesting and weighing na. So, yan. Next po. So, yan. Tapos, sunod po sa carbonization, punta na po tayo dito sa pulverizing. Kasi po, ang kailangan natin sa charcoal briquettes is charcoal fines. Kaya, dapat mapulverize natin yung ating sample. So, ang pulverization is a process of reducing the size of charcoal into a desired particle size. So, during po ng conduct, ako po ay gumamit ng manual. Manual method lang po ang ginamit natin. So, gumamit tayo ng mortar and pestle, wooden mortar and pestle. Tapos, sieve lang po. Kasi, wala naman pong available na charcoal crusher dito sa atin na malapit. And, konti lang naman po ang gagamitin nating sample. Kaya po, nag-manual po tayo. So, next po. So, yun. Next natin, after natin ma-pulverize, we have weighing and mixing. So, dito, ang goal lang naman ng weighing tsaka mixing. So, sa weighing, para makuha natin yung proper proportioning. And, itong sa mixing naman, syempre, para ma-incorporate natin yung ating mga raw materials, para maging consistent yung ating mixture. Para pagdating po ng briquetting process, madali natin siyang ma-mold. So, next po. So, yun. Nandito na tayo sa briquetting or molding. So, briquetting, a process of compressing the charcoal fines and binder mixture into a molder. So, kung makikita natin sa picture, yan po yung sa right, yan po yung manual briquetting press po ng Naga City Sanitary Landfill. So, ang briquetting press po nila ay may 16 molds nung time po na nagka-conduct pa ako. So, sa ngayon po, di ko alam kung nadagdagan na po yung unit nila. And at later po pala, may ipapakita po akong video presentation para po makita nyo kung paano po ang process ng paggawa ng briquettes. So, next po. So, yan. So, after briquetting, nandito na tayo sa final process, which is yung drying na. So, after briquetting, the produced briquettes undergone drying by the use of oven dryer. So, gumamit po ako dito ng oven dryer kasi para mas madali po yung ating drying process. And at the same time, medyo para uniform po yung temperature na ma-receive nila. So, yung temperature po pala na ginamit ko based sa literature is 60 degrees Celsius and for 48 hours po. So, next po. So, yan. Ito po pala yung result ng isang proportion ko na kinonsider ko as best. Ang binder po na ginamit ko dito is yung fresh cow manure. So, ito po yung mga testing parameters. We have the degree of friability. Ang rate niya po is 2.66. So, ang pinakamataas na rating po dyan is 3. So, next, ang degree of friability po pala, ang process po pala ng test na to is ihuhulog natin yung ating charcoal briquettes, 7 feet po. 7 feet po ang taas para malaman natin kung mabe-break po ba siya or hindi. So, ang next naman natin is yung back density. So, ang back density niya is 0.5 gram per cc. So, next, we have compressive strength na may 0.66. So, ang compressive, kailangan natin kunin yung compressive strength kasi ang charcoal briquettes kasi pinagpapatong-patong. So, pag pinagpatong-patong natin, kailangan natin makuha yung ating compressive strength. So, next, we have moisture content. Sa moisture content niya, ang moisture content niya is 9.35%. Base po sa literature, ang suitable na moisture content is 5 to 15%. So kung makikita natin, pasado po siya in terms of moisture content. Next po is ash content. So masyadong mataas po yung ash content nitong ating na-produce na briquettes kasi based sa PAW, ang ano lang na moisture content suitable lang is dapat 3%. So kung titingnan natin, medyo mataas po talaga yung na-produce natin. So next po. So next natin is yung volatile combustible matter na may 28.6%. And sa standard po, ang volatile combustible matter lang dapat is less than 30%. So kung makita natin, pasado po siya, 28.6 po siya. Next naman natin is yung fixed carbon content na may 41.6%. And sumunod po yung heating value. So ito po yung pinaka-importanteng characteristic ng isang charcoal briquettes kasi sabi ko nga kanina, ang charcoal briquettes is ginagamit as cooking fuel. So ang kuha niya pong result is 4,335.5 calorie per gram. So ang base standard na research ko, ang heating value dapat is nasa 4,310 calorie per gram lamang. So kung makikita natin, pasado po siya. Sa water boiling test naman, so ito yung time kung kailan niya mapapakulo yung tubig. So ang procedure nito is 100 grams lang naman na charcoal briquettes ang aking ginamit and also 100 ml lang na tubig yung ating papakuluin. So after 5.28 minutes, napakulo niya yung tubig. So yan po. Next po. So ito po pala yung economic analysis niya. We have ang return on investment niya po 27.4%, payback period na 3.6, tapos yung benefit cost ratio niya is 1.27%. So however, ito po ay based lamang po sa mga assumptions po. So yun. And yan po. Next po. And yun. Thank you very much po.
All right, thank you very much for the insightful talk, Engineer Plamiano. Thank you po.
Thank you po.
Thank you po. And so, the evaluation of cacao pod hast charcoal briquette production is a sustainable and innovative approach to address waste management, provide renewable energy, and support local communities. It represents an eco-friendly solution with the potential to transform agricultural waste into a valuable resource in the fight against deforestation and climate change. All right, now that all our resource speakers are done to share their topic, and we are almost near to the end of our webinar. So for all the students of agricultural and biosystems engineering, to our professionals, agricultural engineering workers, and those passionate about this field, we'd like to ask, have you gained valuable knowledge in our session for today? Sana naman may natutunan kayo sa ating webinar, and we trust that you'll put it to practical use in all your upcoming endeavor. Now that we reach the denouement of our webinar, we are now open for the question and answer portion. So if you have any questions, please comment it below and our guest speakers will answer it. So, meron tayong na-raise na tanong dito. Wala naman nakalagay kung para kanino yung tanong. So, okay lang naman po na kahit sino po yung sasagot sa mga questions. So, yung tanong po is, economical pa din po ba ang use ng fermenter machine na ito on a larger scale of operations? O up to what scale po ng operation mas okay po ito kaysa sa wooden boxes, since we know na mura lang ang wooden boxes kaysa sa machine? Thank you po. And this question is from Sir James Valderrama.
Ako yata ang sasagot na. Okay, so, Mr. Mr. James?
James Valderrama.
Valderrama. Thank you for so much for your interest po sa fermenter. So as mentioned during the presentation, based on the cost and return analysis of using the fermenter with 50 kilogram fresh bean capacity, based on that alone, we were able to conclude that it is indeed viable, economically viable sa scale na po na yun. And one of the recommendations is indeed on upscaling the machine. Depende po sa location kung ilan yung volume na napoproduce nila, then we can always try. So far ngayon, I cannot be 100% sure na it is viable, but based on the current study, I can assume that it is still viable. Kasi sa wooden boxes, as mentioned earlier, and even sa cost and return analysis po natin, mura nga po si wooden box, sabihin natin 5,000, and ang fermenter natin is 53,000. Pero yung napoproduce niya na fermented beans ay almost double than that of the wooden box. Kahit pa i-consider natin na the same yung quality nila ng fermented beans after fermentation. So, nasa-shorten. So, lessen po natin yung labor cost. Actually, yun yung nakababa doon. Lessen yung cost ng labor, and then we have an additional benefit from the liquefied pulp. So, linagyan din natin yun ng cost. Thank you po. Sige po.
Additional
Okay.
Dr. Onyat.
I have additional, in terms of the viability, I'm very sure that this is economically viable kasi not only that it reduced the labor cost, but also yung fermentation time. Kasi yung traditional method, it takes how many days?
Up to 7 to 10 days,
7 to 10 or 3 weeks at most hanggang sa may stable siya, if ever. But if you use yung mechanical fermenter, ay shorten yan into ilang days lang, 3 days,
to 4
diba?
days.
3 to 4 days only. So just imagine 2 weeks at most as against the 3 to 4 days. So ilang volume of cacao beans ang pwede mong ma-process anytime. Diba? So yun ang isang consideration. Ito nga ay sample pa lang yung economic analysis. What more in terms of volume of the cacao beans to be fermented? So natitriple. Okay? So yung
I'd like to
cost,
add po.
syempre,
I'd like to add pala. Sige na.
how much, di ba?
Okay.
How much ngayon ang
Kasi tinanong ko siya kanina.
as of 2023, the research namin ay 250
to 275.
270. Yung assumption nga diyan, magkano lang?
Okay. Actually, ngayon ko lang yung current price pala ng dried fermented beans. Sabi ni Ma'am Nila, tiningnan niya kanina lang.
As of 2023.
2023. 250 to 275 per kilogram of dried fermented beans. So, kaya bigla nag-compute ako kanina kasi nakita ko yung tanong. So, based on the cost and return analysis, it's actually not indicated during the presentation. Ang fermentation cost is about 49 pesos per kilogram. Fermentation cost po yan. So less, with the assumption na during that time na nagkanda ka ng study, yung fresh bean noon ay we procure it at 30 pesos per kilogram. So meaning ang break-even cost of fermentation per kilogram of fresh beans is only about 19 pesos. So, ang based ulit doon sa result ng study na from fresh naging fermented fermented beans, and then further drying. So, ang recovery niya is about uh, 56, 56%. So, therefore, given yon, magkano lang? Magkano lang pala yung cost natin in fermenting and drying the cacao. Tapos ngayon, pagbibili natin, so assuming na lang, kahit 50% na lang yung recovery natin. So, ilan yun? Mataas pa rin. Ipagbibili natin ng 250 to 75 per kilogram. Okay.
May additional question si Sir James Valderrama. Ano po ang pinaka-optimum drying temperature and airflow for cacao? At applicable po ba ito generally sa lahat ng varieties ng cacao?
Saan si andyan ba si Sir? Andyan yata si Sir, Engineer Edgar. Okay. Anyway, para masagot na natin, based on the result, the optimum condition was 58 degrees Celsius at a drying air velocity, air velocity of 0.3 meter per second, and the loading capacity is 6 kilogram per square meter. Ito yung na-optimize natin, ina-validate pa yan, in-optimize, and then validated na yung result na yon. Okay, so that match. Kasi during po, actually pala hindi ko siguro na-mention kanina, during the fermentation process. So hindi lang ang fermentation niya, hanggang po yan sa drying. So we make sure during drying, yung acetic acid niya ay nagpo-progress pa rin. So, dapat we provide the proper condition ng drying niya. So, kaya ito ginawa natin yung drying characteristics. So, ang tanong ulit, is it applicable dun sa variety? So far, this is all, isa pa lang tong another researchable area. This is only applicable to the variety that was used. If I'm not mistaken, is UF18
and BR25.
BR25. Sometimes kasi, knowing na cross-pollinated ang ating cacao, sometimes it's very impossible for us to have really a uniform variety during the test. But para ma-lessen yung na may mixed variety, kinukuha natin yung samples from a farm. So, yun ang isang consideration natin. Okay, thank you.
Baka po may idadagdag pa wala na. Okay po. Next question po from Chewy. Ang cute naman ng pangalan. So, may specific time frame po ba pag-roast ng cacao beans using traditional or the sunlog method? Para po to kay
Oo, si J. Oo, si JS. JS.
Engineer Arcilia, are you there po? Mukhang, ayan na po, ayan na si Engineer. Hello, boss. Ay, medyo mahina siguro ang internet ni Engineer
So,
Arcilia.
the question, narinig po ako?
Yes, loud and clear.
Ayan, okay po. Sige po. Thank you. So, ang question po, cacao beans using traditional method. So, this question is from Chewy. Thank you, Ms. Chewy, for the question. Chewy po ang pangalan niya. Cutie man. To answer that question, usually, kapag nagsasanlag po kasi, ay inaabot ng mga 1 hour ang pagsanlag. Pero, depende din kasi yan sa apoy na ginagamit natin. Usually, nagre-range siya from 30 to 90 minutes or 30 minutes to 1.5 hour yung pag-roast natin using traditional method. Pero nung time na nagro-roast ako, in 1 kilograms, inaabot na siya ng 1 hour ng pag-roast to reach the best quality of the cacao. Itong kaya mo na talaga siyang balatan na very easy. Yung sa sa firmness nung cacao beans natin, yung fracturability, easy to break and rupture. So at 1 hour time frame, doon na natin ma-reach yung good quality ng cacao natin. Pero nagre-range siya from 30 to 90 minutes yung pag-roast natin using traditional method. Yun.
Okay, thank you very much po,
Thank you.
Engineer Arcilia. Sana po na-address yung tanong ni Mr. or Miss 𝐂𝐄𝐄. And now, moving on sa another question from Miss Francel Capiliano Florarita. So, yung tanong po is, are there specific varieties of cacao that are better suited for certain processing methods?
Variety.
Opo, are there specific varieties of cacao that are better suited for certain processing methods po?
Okay. So actually, any variety can be processed, but the most common nga here in the Philippines ay yung BR25 and
UF18.
UF18. Yung Trinitario at saka yung Criollo, ay although high value ito pag pinrocess mo, but the source ng Criollo at saka yung Trinitario, kasi mga hybrid na rin yung itong ating BR25 and UF18. So mostly, yun ang ginagamit natin sa testing kasi yun ang readily available. Very rare kasi yung Criollo saka mahal. Mahirap i-test kasi syempre it will entail a higher cost during the testing bukod doon sa inavailability of ready source variety na yon. But I think hindi naman masyadong problema yung variety aspect.
Okay po. Thank you, Dr. Onyate. May tanong pa po, how much market price ng briquettes? Siguro for Engineer Plamiano po ata to, yung tanong na to. Kung magkano po ang market price ng briquette? This question
Yes
is
po.
from Resali Kaang Dantes.
So, thank you po for the question. Based po sa research ko, ang price range po ng charcoal briquettes ngayon is nagre-range po ng 38 to 40 per kilogram po. Thank you po.
Okay. Thank you po, Engineer Plamiano. Moving on sa
Okay, thank you po.
another question. Okay po. From Miss Rose Hannah Anyes, gaano po ka-importante ang fermentation of cacao beans before drying po?
Okay. So as discussed also earlier, we should provide an environment na especially dun sa first part, actually during the fermentation test, na-achieve niya yung temperature of 47 degrees Celsius in 1.5 days. So under anaerobic condition siya, so no air. So pag nasa po kasi siya for other traditional method, we cannot be assured of that condition. So during the fermentation process kasi doon nagkakaroon ng degradation ng pulp, and as discussed also earlier, yung process na yon, and namo-monitor po natin yung quality ng beans during the process. Actually nakukuha natin yon, and we do bean cut test during the aerobic phase na para undisturbed. Dapat po talaga undisturbed yung ating bean mass bago niya ma-achieve, para ma-achieve niya agad yung desired temperature. Kasi sabi nga natin earlier, based on previous studies, actually yun ang naging, for sure, ang naging basis ng PNS na dapat 45 to 47 degrees Celsius siya. Lesser than that, under-fermented. Greater than that, possibility na over-fermented naman siya. So may gauge po tayo.
Okay. Thank you very much po, Dr. Casino. Another question po, from Miss Louise Margaret Q. Is there a difference in the roasting and fermentation process between cocoa beans grown in different regions of the world? Is there a difference in the roasting and fermentation process between cocoa beans grown in different regions of the world?
Okay. So, I think on the difference kung may ano in a specific country. So, since iba-iba naman ang ating environmental condition, so it's somehow will affect yung fermentation time kasi merong regions na malamig, merong regions na nasa temperate ano lang, okay lang yung ano, meron namang napakainit. Kasi nga yung temperature is the parameter which is very critical in any processing activity. Kasi yung moisture, yun ang nating ano, we should establish an equilibrium moisture content para naman na in storing that product, medyo longer ang shelf life niya. So, yung fermentation time, yung processing time lang ang magiging ano doon. But in terms of the quality, so depende na nga doon sa mga parameters kung properly monitored ang condition ng beans na nagsusurround sa kanya kasi meron naman tayong pagka ano yan, higher ang vapor pressure outside the product, may absorption na mangyayari, and if the vapor pressure of the product is greater than the environment or the air, ay talagang there will be drying that will cause. So yung release ng moisture, kasi yun naman ang ano sa processing yung moisture content kasi yung MC, di ba? Kasi may ano yan, cellulose, sugar content, kaya very prone to deterioration. So it's just a matter of the time ang consideration dyan. Doon lang differ. But in terms of the process and the condition, halos parehas naman din in any parts of the region.
Okay po.
Yun po, I'd like to add, parang hindi kasi, parang hindi yata na-mention, though nasasabi niya yung mga optimum conditions na yun, and the ambient condition, kasi nga iba-iba talaga po ang ambient conditions natin in different parts of the country and of the world. Ano po. But, ito nga po ang pinupush natin yung mechanization. Kasi all of this will be lessen. Yung variability po ng lahat na to ay malilesen if it is mechanized. Ano po? Where we provide, yes, we can always control the condition. So kahit saang location ka ng mundo ay parehas lang yan. Ang condition na ibibigay natin sa bean mass. Opo, thank you.
Thank you po. And may question din po from Sir Louis Samonte Gascon Mabale. Ano po ba ang mga parameters ang need i-consider to gauge the success of fermentation using this mechanical fermenter? Ano daw po ang mga parameters na kin-consider?
I think it was also presented. Number one doon is yung recovery, fermentation efficiency, diba? Na fermentation efficiency, what else? Oh yes, yung factors natin. The temperature, the temperature inside the chamber, yung sa fermenter mismo. So dapat na maintain nyo at a certain time, no? And yun nga po, airflow. Pag airflow, dun naman yun sa dryer. Pa sa fermenter, wala tayong sige. Gusto ni Madam nila i-consider yung airflow.
Kasi sa mixing.
Okay. During the aerobic phase na pala, gusto ni Madam na i-determine yun. So far, hindi natin siya na i-consider during the test. Okay. Sa mga susunod, kaya itong nasabi natin, marami pa ring gap yan. But due to the limitation of time, and of course, the resources, yung mga important parameters muna, so but hindi natin dinidiscount yung mga ibang ideas na yun.
Thank you po. May next question pa po from Mr. June Dumagat Laranjo Ongi. During the roasting of cacao, nababawasan po ba yung taste at aroma pag na-break into nibs?
JS.
Hello po. So yung question po ay yung pag-break ng nibs. So ang tinutukoy niya po ay medyo durog-durog na. Yung taste and aroma po ng cacao nibs natin once na nag-break na siya into pieces, hindi naman po magbabago yung taste and aroma niya. So, ang ginagawa lang natin, yung sa machine po na ginawa natin, itong fluid bed cacao roaster, ang final product niya ay buo pa yung cacao nibs. So, ang mangyayari na lang din, meron kasing different way nung pag-roast. So, meron akong kakilala from CNSC, nag-design din ng cacao roaster. So, ang ginawa niya ay kasama na yung pag-separate nung balat ng cacao beans during roasting. So, ang nangyari, syempre, para maalis yung balat niya, is dinurog niya yung cacao beans mismo, yung roasted cacao beans. But the taste and aroma, hindi naman siya wala naman masyadong epekto kung buo pa yung cacao beans natin or durog na. Sa marketing na lang siya problema kasi pwede nating i-market ng buo pa or pwede natin na i-market granules. Yung durog-durog na pero malalaki pa lang din. So yun.
So in addition, thank you JS. Resources speaker ka na yun. Anyway, dagdag ko lang kasi nagkakaroon ng durog-durog yung mga nibs because of some factors. One is over roasting, and then the other one is you might have processed an immature cacao beans. Yung fresh na beans na pinag-ferment mo and then even dry ay still immature. Kasi to come up with a very high quality fermented beans, kailangan yung fully matured yung cacao beans na ginamit. Kaya nagkakaroon ng mga durog-durog na yon during the roasting process because of some immature gray beans which are incorporated dun sa fermentation niya at saka yung drying. Kaya nagkaroon. Kasi one indicator ng high quality roasted beans is yung buo talaga siya. Yung kumbaga sa yung recovery, yung whole kernel. So mas maraming whole kernels, mas higher din ang quality. Quantity and quality. Kaya yung nibs yan, mga durog-durog na lang. There are some factors. And isa pang factor siguro yung lalo-lalo na kung hindi controlled, kasi syempre yung traditional not controlled, unlike yung mechanical na control mo. Yung mga nibs, marami makikreate baka sa sobrang dami ng pigro-roast mo, nadudurog na. Kasi nga may over-roasting, saka yung time din ng roasting. Yun lang, additional info.
Thank you po. I believe nasa last question na tayo. And this question is from Alana Nicole Giltiano. So yung tanong po is para po ata kay Engineer Plamiano. So regarding po dun sa charcoal briquette na na-mention po na ginamitan ng binder ay cow manure and clay. Pinaghalo niyo po ba yung dalawa or may batch po kayong may briquette na? Briquette na binder ay manure, then batch na clay ang binder. May significant difference po ba ito sa total heating value ng briquette? Engineer Plamiano?
So thank you po sa question. Sa conduct po ng study ko, ang binder na ginamit ko is yung magkahiwalay po sila, hindi po sila nag-mix. So iba po yung charcoal briquettes na na-produce gamit ang fresh cow manure at iba naman po yung sa clay. So sa result ng dalawang binder na to, ang may pinakamataas na mas maganda yung heating value na napoproduce is yung syempre ginamitan natin ng fresh cow manure kasi yung fresh cow manure is may heating value din po siyang na-add pa dun sa ating charcoal briquettes. Yan lamang po.
Thank you, Engineer Lamiana. May katanungan pa po ba?
Okay.
Meron pa pong na-raise na tanong dito. From Sir Heraldine or Kia. Upon knowing the benefits that these machines could give to the cacao farmers, what would be the following actions so that these machines will reach the farmers, especially those financial challenged local farmers? Is there any actions involving our government?
Actions. Okay. So since we have so many interventions na on the cacao in this cacao processing equipment, developing cacao processing equipment, ay talagang continuous promotion and dissemination activities by research institutions is very necessary, and also lobbying from the policymakers to reach the farmers. Kasi we might have several technologies available na nasa nasa drawer lang, or perhaps nasa institutions lang, but it really does not reach the intended beneficiaries. So yung extension mandate ng every SUCs and also yung iba pang mga government agencies ay pagtulungan para sa promotion nito and dissemination. So one way to promote is through publications, and then webinars like this is also very important. Sana nga may mga policymakers dito and may mga processors, not only farmers, but also the technology innovators, marami. At saka, isa pa, there are still lots of problems in cacao industry that we should address. To mention among the problems in cacao industry, hindi lang itong mga taga-engineering departments, hindi lang yung mga processing technologies natin, but also in the production aspect. So this is a multidisciplinary approach if we want really to have or to create the Philippines as one of the leading cacao exporters or producers. Kaya ito po, kung meron dito mga undergraduate and graduate students, I would like to take this opportunity now to post the problems in industry na pwede makatulong, hindi lang yung researchers but also yung mga policy makers, especially kasi kung wala yung tulong ng mga policy makers, ang mga initiatives ng mga research institution ay hindi talaga makaka-reach. So yung communication is very important. So number one problem in cacao industry na pwede ninyong mapagtuunan ng pansin for R&D kasi ito yung mga problems. So non-availability of correctly labeled high-yielding varieties. Kasi na-mention kanina about yung varieties. So ano ba yung mga high-yielding varieties for planting? Thus, the farmers frequently resort to planting low-yielding varieties and poor quality planting materials. Number two, problems in the industry is the inadequate information on the genetic characterizations for specific cacao traits that will improve yield and quality of beans. Number three, low survival and yield in the nursery and plantation due to pest and disease infestation. So mga sa production nito inadequate preventive and control measures against pests and diseases. The low yield due to unproductive and old cacao plantation. So there is a need to rehabilitate this old cacao plantation, that old cacao trees. Kaya yung mga agronomists agronomists dyan, yung mga entomologists should work hand in hand with the processors, the technology innovators, na like yung mga engineers natin. And then also another concern in the industry is the unavailability of reliable maps and information on existing cacao plantings. Kaya nga
Has to
dapat
be
meron tayong mga ano doon, sana naman yan, mga social scientists naman ang papasok dyan. And then suitable areas for cacao growing, okay, mga agronomists dyan. And then availability of appropriate innovative equipment, eto dito na yung mga sa engineers papasok, to detect defects at early stage of cacao processing to avoid low quality products. And lastly, improve the waste management in cacao post-harvest and processing. So from production to processing and waste management are really needed. And then followed, if we have the different technologies now, marami na madali na ma-promote. So we have to communicate to the intended beneficiaries para ang ating cacao industry dito sa Pilipinas ay ma-improve. So, yung productivity natin, di ba, yung knowledge, yung 100% the attitude. So we should always accept challenges in order to improve productivity.
Okay, thank you po, Dr. Oñate. May last two pa po tayong question.
Wala na.
So, from Sir John Christian Serra Villalon, sa cacao pod splitter, were there considerations for compatibility with other processing equipment in the industry?
Compatibility. What do you mean by compatibility? Kasi as far as I know, wala pa namang cacao pod splitter na na-develop. This is the prototype, the initial. Even sa Davao, I had a training on cacao production and nursery establishment actually in Davao sometime in 2018, and wala talagang splitter. And baka marinig ni Sir Val Tortor dyan, siya ang Executive Director ng SIDAMI, yung Cacao Industry Development on Mindanao Association, dati siyang City Agriculturist ng Davao. When we had the training, yun na talagang pinaka-problema, yung splitting. Kasi pina-split talaga kami noon. Meron silang na-develop na semi, yung, di ba yung sa atin ngayon, kung pinupukpok, tinry namin yun, na pinupukpok ng wooden, and meron din yung cutter na ilalagay mo doon yung parang manual din. So that was the challenge. That's why I came up before with initiatives in order to address the cacao industry problems kasi talagang mahirap. And ang hirap talagang mag-split. Pinagkalawa nga kami. Hirap-hirap talaga. So, yun.
Ano yung tanong?
Ano to?
Compatibility. Kasi it has something to do, kasi it could be a function of the variety. Kasi iba-iba yung sizes niya.
Actually, that was during the pre-testing, we tested the small, medium, and large pods.
Lahat naman
Lahat
accommodate.
yon.
Okay.
And then, lahat naman siya actually na-split. But for the sake of, para yung, yung condition ng the testing, we chose the medium size kasi yun yung dineliver, sinort namin yun, but randomly selected yung small, medium, and large. But the higher or the greater number of cacao pods were medium. So we selected lahat na lang ng medium para similar ang condition ng size. But in terms of variety, I don't think wala naman siyang it's only on the size.
Okay. Since ngayon po, variable pa rin yung size, depende sa, of course, yung growing ko, yung production niya. Aside ng, alam natin, different sizes dahil din dun sa different hybrids, ng ating cacao. I think we have 15 clones na ngayon dito sa Pilipinas na registered sa National Seed Board. So iba-iba siya. So ngayon ko lang nga nalaman kay Madam kasi I was not a member of the panel of who presented the splitter. So, pero ngayon, we have an ongoing study. It's being funded by the university. We have now the second prototype of that splitter. So kaya niyang ongoing po kaya niyang i-split kahit anong size, kaya niyang i-split lahat na kahit anong size, and ang modification pa din dito ang development is may kasama na ring bean separator. So pagka-split, papasok siya sa drum, rotating drum para hindi siya i-scope pero kaya niyang separate yung pad from the beans. So hiwalay na ngayon, lalabas yung byproduct na pads and the main product nitong ating wet beans. Ito, ongoing, hopefully first quarter of this next year, we already have that prototype tested. Thank you.
Okay, thank you very much po. Now that we're down to the last questions from Mr. Rodrigo Montero. Para po sa cacao briquette, kung sakali po gumawa kami nito, may suporta po ba? May suporta ba ito manggagaling sa concerned agency? For Engineer Lamiano po, yung tanong.
Kasi ikaw na lang
Kasi
suporta ang
support. So,
ikaw na sumagot.
Ako na sasagot. So, in terms of support, marami namang agencies dyan. The only thing that you need to do is to make a proposal. Kasi without a proposal, wala namang magbibigay ng pundo. Okay? And yung naman, mga research institutions, tulad ng DA, BAR, itong DA sa region ninyo, and other stakeholders involved in cacao industry. Kasi meron naman mga private organizations who are into continuous development. May R&D components yan eh. We have doon sa Davao yung Malagos Farm. Ang anak nun ay AE din, si Angel Fuentes Pina. Yan, baka kilala ng mga taga Davao yan kasi kilala sila doon. Pwede naman silang, kung may proposal kayo, kasi makakatulong naman doon sa kanilang business. Kasi meron talaga mga, yung si Dami, yung sa Mindanao, pwede naman kayong mag-submit. Dito kasi sa atin, hindi masyadong yung kwan. But I'm sure, maraming opportunities, maraming funding agencies, hindi lang natin na-access. So, gawa lang kayo ng gawa. If ever wala kayong contact, just contact your professor kung estudyante ka man dyan. Or kung farmer, just contact yung LGUs, ay makakatulong dyan, and the Department of Agriculture.
Thank you very much po. May nagtatanong lang din po kung pwede daw po makahingi ng mga copies ng mga discussed topics. Like yung PDF file ng lecture. So, isasend na lang po right after the webinar. Hopefully, na-address.
Portable naman siya, diba? Portable naman siya.
So, may last tanong pa po. From Miss Julie, pwede po ba mahiram ang mga prototype ng matesting siya ating sa chocolate making project? Pwede kayang bitbitin ang splitter dun sa mga kabundukan at naandun ang cacao pod? Smart agriculture ba?
Yes, pwede naman. Because, hello Julie! with all pleasure, taga-department ka naman. So, let's help one another. Di ba, sa amin yung primary processing, sa inyo yung secondary processing. So, let's help one another. And in terms of portability, pwede naman mabitbit. Actually, wala siyang, madali naman lagyan siya ng roller na ipupush mo lang parang kareta. Pwede naman yon. And parang it was not considered nung walang roller yata. Hindi ko lang masyadong naalala. But we can always put rollers para
Caster wheels.
portable. And actually, magaan lang naman talaga yun. Medyo malaki-laki lang yung dimension, pero magaan lang yun. And madaling i-carry. Gender-friendly, di ba? Magaan lang siya. Ipupush mo lang, kaya-kaya. Pwedeng bitbitin from Department of Agriculture and Biosystems Engineering papuntang
Hindi daw papunta sa farm.
Sa farm,
Yes.
yes, of course, pwede. Pero bago ka pumunta doon sa farm, doon man yung food tech.
Yes. Oo nga. I'd like to add on that. Nakita ko yung presentation ni Ma'am Julie during the second Cacao Congress. It's just unfortunate that I was not able to be there. I missed that very important event, And doon sa presentation niya, nakita ko doon yung may gap, really. There's a gap. Kasi sa production, wala tayong problema. And then, yung food technologies natin, scientists is on processing. So may gap siya, no? So if I'm not mistaken, it's 35% for post-harvest. So may gap na yon, and actually yun ang doon kami pumapasok. Yun ang ina-address namin, yung primary processing. And we know, yung secondary processing, magagaling sila ma'am dyan. And kaya nga, we would really appreciate if we work hand in hand from production, post-harvest, and then processing. Para kung ano yung requirement sa processing nila, ayun ang isasatisfy namin. May nakita rin akong mga suggestions ni ma'am regarding dun sa quality ng leaves, or the beans during roasting, mga ganun po ba. So, we are trying to fill really the gap, to make sure na yung ipaprocess ng ating mga secondary processors ay really of good quality. Tapos, yun nga, yung required quality para maganda yung result din na naka-chocolate ay maibigay natin. Kasi yun nga, kung sa production pa lang, especially during the primary processing, ay hindi natin naibigay yung best condition for the beans, then affected. Alam ni Ma'am Julie yan, affected syempre yung ang quality ng kanilang chocolate.
Patikim naman.
Patikim naman dyan. Ako nakatikim na.
Sa food tech, ang galing nila sa mga product innovation. Yes. Meron na tayo dyan. Promotion na rin sa CBSUA. Yung food tech, ayan, meron na sila dyan ng mga laboratory facilities. Kaya, we will also produce na commercial products. Thank you, Jules.
All right, thank you so much po. Hopefully, na-address ang mga tanong ng ating Facebook Live viewers. So, it appears that we are drawing near to the conclusion of this webinar. Therefore, I'd like to seize this moment to express our gratitude to all those who assisted in organizing this event and to all who joined and actively engaged during the webinar. We also extend our appreciation to our guest speakers, Dr. Onyate, Engineer De La Rama Jr., Engineer Arcilia, Dr. Pisino, and Engineer Lamiano, for dedicating their time to be with us. So, as a gesture of our gratitude, we will present you with a certificate and a small token of our appreciation. So, allow me to read the certificate citation. So, Republic of the Philippines, Central Bicol State University of Agriculture, Certificate of Appreciation is hereby given to Dr. Nila B. Onyate, ASEAN Engineer, in recognition and sincere appreciation of the invaluable time and expertise rendered as resource speaker during the ABE 190 webinar series with the theme Cacao Processing Technologies and the Pinnacle of Innovation. For the topic of overview of the cacao processing industry, and Design, Fabrication, and Performance Testing of Cacao Pod Splitter, held on November 18, 2023 at the Central Bicol State University of Agriculture, San Jose, Pili, Camarines Sur. Given this 18th day of November 2023 via online conference. So, this certificate is for Dr. Nila 𝐂𝐂𝐿𝐿. Thank you so much po.
Picture.
Yan. Yan. The same certificate is hereby awarded to Dr. Marife L. Pisino, ASEAN engineer, for the topic of design and development of automated cacao bean fermenter. So this is for
Thank
Dr.
you.
Pisino.
Thanks.
Thank you so much po. The same certificate of appreciation is hereby given to Engineer Edgar Martin Y. De La Rama Jr. for the topic of drying characteristics of cacao beans. This is for
Ayan, sir. Ayan na ha.
Tao mo man
Oh.
virtually. Tao mo man virtually.
So the same certificate also of appreciation is hereby given to Engineer John Smith Arcilia for the topic Design, Fabrication, and Performance Testing of CBSUA Fluid Bed Cacao Roaster.
JS. Sorry, sabi ko kanina, nasa CNSC ka pa. Mag-blowout ka, nasa ATI ka na pala ha. Dito ba sa region?
Kagirit.
Region?
Yes po, ma'am.
Congratulations. Lapit ka na sa amin.
Okay. And lastly, the same certificate of appreciation is hereby given to Engineer Eman A. Plamiano for the topic of evaluation of cacao pod husk for the production of charcoal briquettes.
Sa ating fresh
Fresh graduate.
Fresh graduate
Thank you po.
full newly licensed Abe.
Thank you so much po.
Di ba? Bless. Thank you. That's akin. Claim it.
Again, thank you very much to our honored guest speakers. I would like to remind everyone then that the evaluation form is already posted in our comment section. So, pa-fill out na lang po para mag-grant ang inyong e-certificates. And now, before we conclude this webinar, I would like to invite one of the members of my team, our very own Miss Julian Orlina, to convey a closing message to our viewers.
A pleasant morning to each and everyone. First and foremost, we would like to extend our deepest gratitude to our speakers, our faculty and alumni from the Department of Agricultural and Biosystems Engineering of the CBSUA. We have Dr. Marife L. Pasino, ma'am, Dr. Nila 𝐂𝐂𝐿𝐿, Engineer Edgar Martin Y. De La Rama Jr., Engineer John Smith Arcilia, and Engineer Eman A. Plamiano. Thank you for accepting our invitation and imparting your knowledge and expertise about cacao processing technologies. We'd also like to thank you for giving your time and joining us in this event even though it's a weekend. Second, we would like to thank the Extension Services Division, Sir Marvin and Sir Froy, for accommodating and helping us throughout this webinar series. To the CBSUA-DABE, headed by our Dean, Engineer Karen May R. Lim, our Program Chair of BS-ABE and Advisor, Engineer Lynette C. Alto, and to the whole DABE faculty for your unwavering support and assistance in making this event happen. And of course, thank you to everyone who participated and joined the Facebook live stream. Without all of you, this webinar series would not be a success. Cacao is widely known for its various applications and uses in the industry. Additionally, it is also known for its high value in the market. And as mentioned earlier, sabi nga po ni Dr. 𝐂𝐿𝐿, napakataas ng demand ng cacao not only here in the Philippines but also globally. Bicol region's top products include cacao. However, Region 5 is only part of the 3% in the top producing regions in the Philippines as what Dr. Nila have mentioned earlier. Now, as future agricultural and biosystems engineers, it is our duty to address any issues concerning cacao processing, and one of these is developing appropriate machines and equipment for enhanced process efficiency rather. In the presentation, we have learned that the cacao processing industry has so much potential only if it is maximized. Our dear speakers highlighted innovation through their studies and researches, and we saw how improved cacao processing is rather than before na traditional ang ginagamit natin. It was also mentioned that parameters such as temperature, moisture content, airflow, that shall be considered for optimum yield. Therefore, we conclude that mechanization plays a vital role in enhancing process efficiency. It is an important tool not only in the cacao processing industry, but in the agriculture sector in general. With that, I now formally close this webinar with a reminder na do not be afraid to take the big step and unleash your potential in innovation and development. Sabi nga ni Dr. Aniate kanina, are you ready to take the challenge? The answer is yours. Again, thank you very much and may God bless us all.
Thank you very much, Miss Erlina. So we hope the knowledge you've acquired won't remain dormant, but will be disseminated and put into practice. Thank you once more for your continuous support, and we eagerly anticipate your presence again next week on November 25, 2023 for another upcoming webinar entitled Climate Controlled Structure, a Key for Biosecurity in Swine Production. Wishing you a fantastic day. Thank you, everyone.